All right. SD-WAN, we discussed about various components. Basically, the five components together will form the complete fabric. vBond and vManage, vSmart, vNedges, and vAnalytics. And also on the orchestration plane for zero-touch provisioning or PNP services, we do have ZTP server and PNP server. Then these components, are whitelisted. So basically, by making the manual entries about allowed controllers and then allowed managers, whitelisting communication. Then device digital certificate. So all the devices, including controllers and managers, are added with the device certificate. So by exchanging the device certificate, mutual trust gets established between them. Then we run OMP routing protocol between WAN edges with vSmart, and also it runs from vSmart to the other vSmart, exchanges different types of routing parameters like OMP, service VPN routes, TLOG routes, IPsec encryption keys, and then policies. We create centralized policies in vManage, and these centralized policies are advertised to vSmart via OMP protocol itself. And then if we go with any L4, L7 functionalities, so even this function routes will be advertised over here. Then data plane. So data plane, all advantages forms VPN tunnels with each other, and these VPN tunnels are permitted through IPsec manner or the GRE manner. So obviously, like the default behavior is the IPsec encapsulation. And then to validate the tunnel quality, and then we introduce BFT, so bidirectional forwarding detection mechanism. So BFT analyzes each tunnel status, whether it is up or down, and then tunnel loss, latency, and then jitter. So the metrics are calculated for this path through the BFT mechanism itself, and then maximum transmission units, so maximum payload size permitted over the VPN tunnel gets validated through BFT itself. So one protocol for tunnel liveliness testing, and also loss, jitter, and then latency testing, plus like maximum transmission unit supported over here. So complete fabric supports with control plane communication, OMP communication, data plane communication with BFT features. Then second logic, we went with device management. So device management with the help of device template. So this device template will carry the complete configuration for the devices, including system configuration, VPN 0, VPN 512, service VPN, and additional system related configurations. So these configurations are carried through CLI based template administration or feature templates. So we carry various feature templates by connecting feature templates into device template, and device templates in a GUI manner we can be able to enforce. So device template can be created and can be mapped to the devices using CLI format or the feature format, feature template format. Then we talked about zero touch provisioning, automated deployment and provisioning of vanages, and including Cisco boxes, and then the viptela boxes, both in physical and then virtual form factors. So zero touch provisioning, we maintain ZTP server in the public network, and with the help of ZTP, all the devices are automatically provisioned. Similarly, PNP, and Cisco maintains the PNP server. All C edges will talk to PNP server using the PNP infrastructure. They will be redirected to our internal fabric. So automated deployment for V edges using ZTP, and automated deployment for Cisco edges through PNP. Then virtual machine based devices through the cloud init and the bootstrap configuration file. So using the for example, collecting the chassis ID of the WAN edge uploaded list, and then associated token created. So we will upload along with the vBond. So virtual machines will talk to the vBond directly. So virtual machine-based instantiation process in the name of VH Cloud or software VH's activation or the provisioning process. So using ZTP or PNP or software VH activation process, the devices are automatically placed into Fabric. So those logic we discussed, and then policies. So as part of the policies, centralized policies are created on vManage and will be presented to vSmart. Then vSmart will look into, is there any control policy? Locally, this will execute. If not, data plane and application aware routing policies, they will be presented to the vManages. Localized policies, vManages are going to take this localized policy from vManage itself. So we create the localized policies, and in the localized policies, we determine whatever the data plane and then control plane configurations we wanted to filter. Then vManage will push them directly into the vManages. And these localized policies are communicated to the vManages through template itself. So centralized policies will go directly from vManage to vSmart and vSmart to vManages. Localized policies will go from vManage into vManages directly through the template. So control plane policies, basically they will involve with routing protocol infrastructure. So centralized control plane, we do define policies which influences OMP at vSmart, and centralized data plane. And this is going to influence the data traffic across multiple vanages. Localized control plane, the localized routing protocol architecture of every vanages like OSPF, BGP, EIGRP, we will influence route filtering. And then similarly, data plane communication, like we do have access list to be enforced, mirroring, and then monitoring to be enabled for these kind of managing devices. So various options to create the policy has control plane centralized or data plane centralized, application aware routing centralized, then localized data, and then localized control plane. So finally, they are created as either centralized policy or a localized policy. In one centralized policy itself, we will include sequence 1 for control policy 1, and then sequence 2 for data plane policy, then sequence 3 for application aware routing policy. So multiple control AAR data plane policies are included as part of one centralized policy, and this centralized policy will be activated through the complete fabric. Okay, so this is a point we had discussed, and then we had demo and configurations about this logic. Okay, so now we talk about additional features and additional options to be enabled on top of the fabric. So now, if you look at the fabric is created, so we called the vBond, we call the vManage, and then we placed vSmart, and then branches, data centers, campuses, location sites, all the physical locations, and then cloud-based data centers are deployed with Vanages in the physical form factor or the virtual form factor. Then our fabric initialization component, creating the template, whitelisting of the configuration, and then integration between these devices. Then control plane, OMB, data plane, tunnel configuration, everything is fine. And then policies we created depends on our requirement, even they are also in place. Now, the complete enterprise network is operational. Then once you look into the complete operational network, data will go from branch to data center, branch to cloud-based data center, or branch to branch, or data center to data center. Then through VPN tunnel, the data communication takes place. Now, there are challenges regarding the security. If you look at, if we are connecting Vanages with MPLS, obviously MPLS are like a trusted network and then trusted boundary. So we don't need any additional security for these Vanage devices, maybe CH or VHs. But when internet connections are terminated, when 4G, 3G based public internet circuits are terminated, then the routers are insecure, then we have to provide or we have to protect the secure device manages itself. So this SD-WAN security feature is going to enable SD-WAN associated standard security for this WAN edges. That is, it's not going to only act as the WAN edge router. On top of that, we can tell this router will be initialized with firewall functionality. This can be initialized with IPS functionality, or it can be initialized with proxy functionality, or it can be initialized with web and then URL filtering functionality. So DNS filtering functionality. So like security devices and security feature functionalities can be enabled on top of WAN edge itself. Meaning that for data center, we can suggest or we can go with some kind of good firewalls or external firewall, IDS, IPS, load balancing devices. You can implement it. For the branches security, we don't need to have any security devices. By introducing WAN edge router itself, the router itself will act as a firewall. The router itself will act as an URL filtering device. The router itself will act as the DNS security devices. And like this kind of layer 4, layer 7 security functionalities, we can be able to add it on. So this SD-WAN security logic is nothing but along with WAN edge routing functionality, participating in the control plane and then data plane communication. We are converting or we are adding some more applications for firewall services, IPS services, and then AMP services, DNS security, and then web layer security or URL filtering security things. So that is the idea of introducing security component and top of the WAN edges. So this is obvious that routers are going to be for only routing functionality. But on top of that, while we are enabling security, external devices or additional devices, we don't have to buy Cisco firewall or Juniper firewall or Checkpoint firewall. So we don't have to buy firewall in place. Similarly, IDS, IPS, external devices, we don't have to buy. Proxying devices, we don't have to buy. So no external devices you don't have, you have to buy for these branches and then campus location. So by eliminating the external devices, this security functions and then configuration, we do it on the router itself. So this additional behavior, we will be discussing like what are all the additional security behavior can be enabled and how to enable them, how to provide the security and then configuration for these boxes.
So that's why because maximum already when the traffic, the data traffic which will be going on the transport VPN from one VH to another WAN edge, I mean from one side to one side. So obviously you will be forming a tunnel, IPsec tunnel, and the complete data will be encapsulated, and you will be having a encryption and decryption concept, so that the other side he has to use a remote key to decrypt it, and he has to check on those things, and all kind of customization manipulation we can do it via policies. So on top of
Right.
that, we need these things like, I mean, AMP, all those things. This is an additional features which we can do on the edges itself, or we have to have a separate layer for this.
No, we don't have to buy separate layer and then separate devices. So this WAN edge router, maybe V edges or C edges, this WAN edge router itself will be enabled with its additional features. Like WAN edge router itself can act as a firewall. WAN edge router itself can act as an IPS. This can act as an URL filtering devices.
So you mean to say that the ISRs, CSRs, and ASRs will itself, if you buy an additional license for IPS AMP, it can act as a uh, edge router as well as all these functions.
Exactly. So the idea here, whenever the data goes from branch to branch, private network to private network, we don't need any security because it's like private to private, and the data goes over the private and then public network, encapsulation, decapsulation, encryption, security will come in picture. Similarly, branch to data center also, network communication is secure. Suppose in a branch, guest users are available and guest users needs internet access, internet connectivity. In this case, what happen? Guest users, they will be connected to a different VRF and guest users should have dedicated internet link. So they can have the MPLS connected as well as internet link connected, but data will go from private branch network to internet, and the response is expected. Similarly, some people will try to go for cloud-based network reachability. So public network access will be available for the WAN edges. Now, in this case, guest users are allowed to access only this kind of URL. They are not allowed to use any other URL. And guest users are allowed to access only this traffic, port number TCP 80 and then port number 443 with the TCP or DNS. Only this traffic, they are allowed to access. Then other than that, they are restricted. So if you want to enable this kind of functionalities, obviously we need to buy for firewall filtering. Again, one firewall we are supposed to use it, and then proxying devices or an URL web URL filtering devices. We have to buy and we have to connect in line, and then configuration and local management was required. Now, just to avoid that, you enable all the functionalities in a router itself by configuring what URL is permitted, blocklisted URL, and then whitelisted URL. Based on that, advantages will permit that traffic. So by cutting all the other external devices, so WAN edges are going to take these additional functionalities.
So wouldn't it be a overhead for the managed routers? Like, I mean, because the independent devices has its own, like if you take firewall like a Palo Alto or a checkpoint firewall, it has its own features and all those things. Like, I mean, the number of throughput connections and the number of outbound connections. Like, I mean, for if you take it as a proxy or a firewall or an IPS or an IS or any AMP, FTD, anything if you take. So it has its independent features when it comes to hardware level as well as these things. Because the next generation firewall is something which we have from the hardware also. So doing all these kind of functions integrated in the managed routers itself, but would it be I mean, is there any specific limitation, or would it be functional as how the other the hardware devices function?
No, it will function, but to be honest, it will not be as the real firewall functions and then real IPS function. But up to 75 to 80% of the functionalities and then feature we can bring into these routers. Because up to certain level we are allowed to configure, and let's say stateful firewall. So stateful firewall functionalities are enabled, or it can be placed as an firewall. What traffic is permitted, what ACL, and then what communication we are going to do, they will be placed. But in case one device goes down, again other devices become the primary and standby to active, and then the existing connections will be permitted. So those kind of logic not be followed over here. So up to
Yeah.
75 to 80% of the other appliances or other external devices functionalities we can do. But the best option or best suggestion from Cisco is don't introduce these features with the routers available on the data center side. For branches, you can do that, because a branch with only 10 users, a branch with 50 users. So branch with the limited users, you don't have to invest a separate firewall. You don't have to invest a separate IPS URL filtering. In that case,
Oh, okay. Okay.
users traffic will be limited, and load of the router also will not be much. So what happens, you can do like by enabling this kind of security features, then you can provide security to the enterprise branches.
Okay. So it's completely depends upon the size of the network and the design of the network.
Yeah, so size and then design of the network plus load also you need to consider how much data
Yeah.
traffic
Yeah.
expected from
Throughput.
the branch,
Yeah.
the network, and also like performance, what hardware we are going to use it. So by introducing VH 100, we cannot have all the supported. But when we have VH 1000 or VH 5000 or ISR and then ASR devices, obviously you can enable these features. So by enabling
Okay.
ASR, ISS will not be impacted. So it's a good option for small size networks and then small kind of branches to be enabled with it.
So when we have these functions integrated with ISRs or ASR, so we would be, I mean, we will be managing these services like AMP, proxy, IPS, all these DNS, all these functions. We will be managing it through a software or from an hardware level.
No, it will be managed to vmanage itself. Okay, normally what happen? The way we creating policies, right?
Yeah.
Centralized policies. We create list one. In the list one, site list, VPN list, and then TLOC list, and then match TLOC or match OMP, match IP, and then action. So we are creating the policy. Now these policies are given to vSmart. vSmart execute. The same way we create security policies on vmanage. Okay, for example, I'm creating one access list in the vmanage as part of firewall policy, one URL filtering policy to make some whitelisted and then blacklisted URLs information. So immediately vmanage pushes this URL filtering policy to all the manages are enabled with it. So that means these security features are configured as a policy, security configuration policies. From vmanage, they will be enforced directly to all the managers.
Okay, okay. Because normally when we get an independent physical appliances, so that hardware, so we will be managing that things using a software. Like in case if we have to push a policy or if we have to create an object groups or anything as such, like proxies and anything.
Mm.
So appliances will be there and they will give a respective software to manage and push the configurations to the hardware. So that's what I just wanted to understand. So whether the ISR or CSR, other managed routers will do the same thing, or it's only the software which has to manage everything.
Okay, the way like we are configuring template based information to the devices, policy based information to the devices, along with security policies. Now you can call them as a security policies. The way centralized policies are created, centralized data and in control, security centralized policies are created in vmanage. Vmanage will tell, okay, you take this ACL for the first port, and you take these IPS policies, you take these URL filtering policies, this DNS security policies. So vmanage will push all the policies towards to these managed devices. So we don't need any local configuration or local administration for these devices. But monitoring we can do. So this is enabled with URL filtering. So what URLs are whitelisted and then what URLs are blacklisted, and hits under the blacklist any banner message is set and then what banner message is set. So these kind of verifications we can do it through the Vantage itself.
Okay. Okay.
Okay, right. So in that one, there are Cisco predetermined security bundles by enabling the security bundles. For example, first security bundle as cloud and DIA. So cloud and then direct internet access. So whenever Vanages are having direct internet connections or direct cloud connection, any traffic going towards to internet or any traffic going towards to public cloud infrastructure. So this is suggested, okay, on all Vanages you enable firewall. So firewall functionalities will be enabled. IPS functionality will be enabled, DNS and then web layer security, that is URL or web layer security will get enabled. So DNS queries will be inspected, and then HTTP and then HTTP's query will be inspected. Okay, or industry compliances. So now I don't need any direct internet connection. I don't need any direct cloud connection. All the data goes to my data center. Through data center, they will be going to external network. In this case, advantages can be permitted with firewall functions and then IPS functions. Okay, if guest users are connected across the branches, guests are connected through a different VPN, then for guest services, we can enable firewall and then URL policies and AMP, so Tls. So this is like a standard bundles predetermined in the Vantage itself. I mean in the vmanage itself. By enabling each and every bundle, Vanages will be enabled with this feature set. If we don't want, now I don't want to enable all three or all two or all two services. I want to make like a firewall to be enabled and then URL filtering to be enabled. I want to customize it. So customized functionalities or customized security bundles for the device, even that one also will be permitted. So standard bundles can be enabled, or we can customize the bundle based on that what functionalities additionally we wanted to enable to the devices. Even that one also we can do that. So Vanages can be enabled with security bundle features. Depends on the configuration. Security bundles associated policies will be enforced.
Parthiban, like, so if for example, if I'm reaching some servers on the internet, so from my campus, from my vantage, going to the data center, and from there it's get filtered or checked, whatever verified, and then going to customer. So wouldn't be then taken higher RTT or?
Okay, there are two things. One is you have benefits. Okay, the benefit when you see here, security compliance, you can make sure. Branches, campuses, location, they don't have local internet in the sense like they don't need any additional or local security configuration. When they are going to the data center, on the data center, centralized monitoring you can do. If branch one wants to access something on internet, it goes to data center decides from this branch internet traffic is permitted or not permitted. Okay, one thing is like the drawback, you can call it as more data will come towards to data center and will be connected to internet. But in security perspective, in the compliance perspective, it's a perfect match. So no branches are having local internet, they don't need any local security. All the traffic will come to data center or the regional hub. From there, they will go to the public network. Whatever the cost, you use it for a local security. Okay, buying the local internet connection, buying the local firewall or IPS, and then local licensing for these devices. Instead, you buy higher bandwidth, provide higher bandwidth communication from branch to the data center, and you buy higher devices on the data center itself, and then connect them to the public network. So,
Okay, okay. So you mean to say that so if I have 100 branches, then I have to deploy all this kind of like IPS firewalls, URL filtering, and all this stuff independently for all the sites in case if I have to reach the destination, and all kind of filtering has to happen locally and it has to go out. So rather than that, we will just put it in one data center. Let all the branches or wherever, whether you are coming from a hub or whether you are coming from a different branch or headquarters, come to data center, get your verification authenticity done, and go get out.
that's it.
Okay.
So, yeah, compliance, the entire network security will be controlled through one place. And also, you have a good visibility. So, what traffic is going from where the traffic is coming, what traffic is entering into the branches, the complete network management and then network security also could be easily monitored and then managed. So, that is like kind of a different option, like PCI compliance, maybe like banking or e-commerce locations, or mostly like banking sectors, or kind of important data, maybe like the people they wanted to maintain their own network with compliances, they designed like this. Or common infrastructure. This is like we have end users like local. We don't have any important production data, and even if some traffic is influenced in the branches, we don't have any important data, so nothing will happen. So in this case, you don't have to take all the data into data center, so you can take local internet connection by enabling like this kind of small security feature. You can tell that guest users make local internet. They don't come to Fabric. They don't come to the data center. Like local management also you can. It depends on the traffic, what it is available. It depends on the organization's nature. We can decide it's PCI compliance based connections, or it's like a local connection, whatever it may be the situation.
So, Parthiban, I'll just give you a scenario with the kind of services that we provide. We will have multiple customers within IBM. Okay, multiple customers, multiple security policies, multiple, you know, I mean, different kind of security policies like HIPAA, PCI, and these kind of policies. Can we all deploy them together on one single VH router, or how it is?
Yes, yes, that is what we are discussing. We can do that. So one VH, in one VH itself, you can enable, let's say, IPS functionality or AMP functionality to filter the files and then folders communicated. URL filtering, DNS, and then web layer security. So we can take all the security concepts in one point on the VH itself. We buy only VH, we deploy these VHs into the branches, and in the branch VH, we will place, okay, this is the router, and then making VPN communication to data center and other branches. But any data goes to internet, it filters traffic based on ACL, it filters the traffic based on IPS, it filters the traffic based on URL, or whatever it may be the additional functions we try to enable on it.
And how about packet shaping? Do we have packet shaping functionality included?
No, packet shaping is not supported here. WAN optimization is supported. The way like riverbed WAN optimization. So one side compression, compress the traffic into the pipe of the WAN side, and then other side decompression, and then taking plain data into the destination network. The same way, WAN edges can do compression in one place. Compressed data can go to the VPN tunnel. The other side decompression, and decompressed traffic will go to the data. So compression is supported, packet shipping is not supported.
Okay.
So we already have one. So for WAN optimization or WAN accelerators, we have riverbed still hit devices, which it does the WAN optimizations. Now anyway, so because of this all SD-WAN migration, they may take off these WAN accelerators. Yeah. So packet shaping has to be done. So that for that packet shaper has to be there. If we have to do that level of optimization, because that is meant for that. From a router perspective, we can do some class of service, quality of services with some policies we can manipulate, but it is not effective as what we do with the packet shapers.
Okay, Naveen. So, see, when they have included firewall, DNS, web layer, security, IPS, I thought, maybe in any one of the bigger model, or they might have introduced that packet shaping as well. But anyhow, let's move forward.
No, who knows? Maybe in future it might be introduced. You don't believe that when viptela introduced, so viptela came with only SD-WAN solution, in the sense like it supports only encrypted and then encapsulated communication. And when Cisco acquired, then they introduced security bundles, because a lot of security features are Cisco supported. So they wanted to call all security bundles on top of that. Then later on, they introduced WAN optimization, like acceleration. So WAN edges will do optimization in one place and then de-optimization in another place. So WAS, Cisco WAS functionality they introduced. Okay, now you talked about load balancing. I'm sorry, packet shaping. So who knows, like if Cisco come to know that, and they may introduce this one also in future releases, and they can also be supported. But currently they don't support, but in future it may be.
Okay.
So we will talk about one or two examples with this.
So,
Even
so Parthiban, one small question. So, when we procure one V-Edge router, all these are part of it, or do we have different kinds of licensing for firewall, DNS, web layer security, IPS? Is it
okay, no, you have to take the security license. Okay, so DNA essentials. Once you take DNA essentials or DNA advantage, basically while you're purchasing the additional license, then these security bundles can be enabled. As part of the security bundle, all the features you can run. For example, firewall or IPS or URL filtering, anything we wanted to do, you can do that. But the total license or total bundle license, you will have to purchase it.
okay?
And second consideration is the hardware. Suppose you have VEdge cloud, for example, and virtual machine based edge router. So this virtual machine based edge router, though you have the license to operate all the functionalities, it might not work with some of the features. But when we purchase the physical router like ASR and then ISRs, On top of ASR, while you are calling these security bundles, all the features can be enabled. So it depends. The software license will allow you to enable all the features and then function, but it depends on the hardware model, or it depends on the device WAN edge what we purchase. Then number of features and then number of functions will get deployed.
Okay. So security as a bundle, complete one bundle, or do you have multiple options there as well?
No. One security bundle. So one bundle if you purchase, and then inside that, whatever the security option like firewall, web and DNS layer security, IPS, URL filtering, AM. I think these are the core features you can do, plus proxy. So proxy communication also you can do that.
Yeah,
Then
okay.
yeah, one bundle, and a second bundle for cloud services. By default, standard license will be only for branch to branch or branch to data center VPN, that is encrypted and then encapsulated communication. If you want to go with cloud-based connection, like cloud-based connection with infrastructure as a service or software as a service, then additional license. So one common license or one base license for the fabric function, cloud-based connection, cloud-based licensing we need to take, and security function, and then security-based licensing we have to purchase.
Okay.
Okay. Now, SD-WAN security, various use cases, in which scenario we will introduce cloud and DIA, and in which scenario like firewall and then IPS. So what is this cloud and DIA? Industry compliance and then guest service. So industry compliance is the first option, or PCI compliance. So this is our scenario. We have branch and data center. Users from branch want to talk to the data center, as well as users traffic towards to internet or to the public network. So users traffic from branch to data center from private network. So you can see here. So the traffic coming from here into the private network. So from private network, the data has to go to the private network. So private LAN side to private data center side. So always this place data will be encapsulated and then encrypted. It will go into the VPN tunnel. And then here the VPN tunnel will be terminated. The encapsulation decryption, normal packet will be taken into the data center. Now this employs internet traffic. I don't want to make any local internet exits. I don't want to make any local direct internet connection. All internet traffic will go to the data center WAN edges, and through this data center WAN edges, they should have a backhaul connection, or they will have a connection from data center to the public network. So in this case, Cisco's recommendation, these advantages can be enabled with this PCI compliance security feature bundle. That means these advantages you can enable enterprise firewall and application aware routing plus IPS. So IPS and then enterprise firewall. So these two functions you can enable. So by enabling ACLs for the application firewalls, and then by enabling the IPS policies, this kind of requirement can be like function, can be work. So HQ destined traffic and then employee internet traffic. So this is going to be the situation, and Cisco's recommendation to enable PCI compliance with these two functions on this WAN edge of devices.
Even though the traffic is tunneled, I mean, on an IPsec secure VPN, so still it is advised to have the IPS and application aware routing to be enabled on the managers.
Yes, because the data goes to internet and then data comes from the internet, right? So they are trying to permit it. So if it is a best practice design we wanted to do, we can have two tunnels. For example, this WAN edge can have MPLS connection and then terminated to WAN edge, and then internet connection terminated to WAN edge. So this is your MPLS path and then internet path. So now what happened? If employee to data center, any private to private, for example, destination application or destination subnet, so we can enable application aware routing policy. So we can enable the application aware routing policy. Based on that, you can tell this traffic can prefer to go through MPLS circuit. Then data goes into data center through the MPLS path. Now we can choose from private network, any IP goes to the destination of public IP address. Then you can send the traffic through the second VPN tunnel, that is internet facing VPN tunnel. From here, the traffic will be de-encapsulated and then decrypted. They can go into this place. So this device is going to perform the de-encapsulation decryption, and this is going to inspect, or this is going to take what traffic is going to go to the internet. So this traffic only for VPN2 or only for the dedicated traffic, you can enable the IPS feature, and then you can separate it. So segregated traffic towards to internet, segregated traffic towards to MPLS. We can balance it. Okay, so even worst scenario, what happened? Any traffic going from branch to data center, you call to one VPN, one VRF, and public traffic going from employee to public network, you can call into a separate VPN. So VPN 1 goes from branch to data center, then take it through the MPLS primary path. Any traffic going from VPN to public network, you enable with enterprise firewall functions or IPS function, whatever may be the security features to be enabled on top of that.
Hey, Parthiban, what is that PCI compliance?
So
Did I
PCI
miss?
compliance is a general terminology. So PCI compliance,
Payment card
the
industry compliance.
That is for US standard, right? That is a PCI, that payment card industry data
No.
security
yeah.
standard. That is different, or this is different? I mean, both are
See,
same.
No, both are. It's a general terminology. That means entire network traffic is centrally managed.
Yeah, the same thing what we use, Rudresh, the PCI normally in audits and all those things we use, right? PCI, it should be a PCI standard, PCI HIPAA standard, so like that it is.
see, PCI is payment card industry standard.
Yeah. So that I am aware of it. That that payment card industry, that now some of the account, it's applicable, right? Some of our clients. So is the same thing or different? So that's what I was asking.
Same. Standards are same. Because as it is exposed to internet, so it is a mandatory and it's a best practices what Cisco is recommending to enable IPS and application aware routing on our WAN edges.
Okay, this is like a same kind of security policy for the entire network. That is what basically the compliance. So it's a general terminology what I'm trying to say. Compliance means a common policy or common settings across. Let's say in India, in IBM, a guy goes with Android phone with software version 1, and same software version is not permitted. Maybe that is permitted through an advanced iOS version in US or UK, and vice versa. So a laptop or operating system with lower images supported in US and then UK, and then in India this is not supported. So this kind of situations are remote. So whether the user is connecting in Bangalore or in India region or US region or UK region or whatever may be the place, and he has to meet, this is the operating system on his mobile phone, this is operating system on its laptop, and this is operating system to be available or security bundle to be available. That means a common policy or common functions or common requirement we are going to enforce throughout the entire network. So wherever we are making a common functionalities or common requirement across all the places, they are defined basically as a compliance. So in this case, what happened? PCI compliance, like all the advantages and its internet traffic will be handled through the data center itself. Now, in all advantages, we are enabling firewall and then IPS feature sets. Okay, all right. Yeah. And the second option is guest access. Suppose we have a scenario, employees are connected with the branches, and similarly, guest users also connected across the branches. Now our design says this VPN 1 is going to take the employee traffic for both data center as well as the through data center, the internet. VPN 2 for guest users, but these guest users are having direct internet connections. So DIA, direct internet access. If this is the case, guest users can be protected, what URL they are permitted, what URL they are restricted to access, what file they can download, and then what file they are not allowed to download. So if you have a situation that employees, guest users are connected across branches, employees traffic will be through PCI compliance, and then the guest users connection, and then guest users traffic through the local internet circuit. So Cisco's recommendation to get enabled with enterprise application firewall and then URL filtering. So IPS is not needed. It's not recommended from Cisco as a basic practice. So we enable firewall so that through firewall, what traffic is permitted to internet and then what traffic is permitted in the reverse direction, URL filtering, and for the guest users or for the employees, what URL is permitted, and then whatever may be the URL restricted and then URL permitted, you can define it. So HQ destined traffic to the data center, employee internet traffic to the data center from their backhaul to internet, and then guest internet traffic through the direct internet connections. Okay. Suppose we have the third option. Okay, third case as direct cloud access. So VPN 1 and VPN 1 for employees. So employees will have different traffic to go to internet, traffic to go to cloud-based application, and then traffic to go to the data center, and also guest users are permitted on the uh, branches. In this case, direct cloud access, the security bundle we can enable by enabling direct cloud access. Obviously, the advantages are enabled with enterprise firewall and application aware routing features. IPS features will be enabled, DNS and web layer security. So remember, direct cloud access is not enabled with URL filtering. So URL filtering is not supported here. But if you want to include that feature also, then you don't choose the direct cloud access mechanism. Instead, customization you can plan, and with a customization you can choose to enable firewall, or you can enable IPS, or you can enable web layer security along with URL filtering logic. So when we have direct internet access, so employees internet traffic, employees cloud application traffic, guest users internet traffic, and guest users application traffic, and then employees data towards to data center. So we have direct internet access so that all public traffic will be handled. Only the branch to data center traffic will go through the fabric using encapsulation and then the encryption mechanism. In this case, Cisco's recommendation to go with direct internet access bundle. So firewall can be enabled on the router, IPS can be enabled on the router, and then DNS plus web layer security can be enabled. It's all like Cisco's standard recommendation. If this is suitable for our network, we can choose it, or we can customize it. All the security bundles are available. We can customize from here. I don't want DNS web layer security. I want firewall, IPS, and then URL filtering. Only these three you can customize it. Or enterprise firewall, DNS web layer security plus URL filtering. So any combinations we wanted to introduce, we can customize that as well. Okay. So by enabling the SD-WAN security, this SD-WAN security configurations are created using policy only. The way like centralized policies are created in the vManage, all security configurations will be created as a security policy using commands only. And these security policies or security commands will be then enforced from vManage to all the manages. So compliance, if you choose to enable compliance security bundle, then under compliance, we are allowed to enable function and then IPS. So application firewall, the policy rules we can do ACL1, ACL2, ACL3, source destination IP, source destination port number, protocol number we can do, and then IPS functions we can enable. In case of guest access bundle, application firewall, and then URL filtering configurations will be applied. Direct cloud access application firewall, IPS DNS security. Direct internet access DNS security, URL filtering, IPS, and application firewall. Now we don't want to have all the things. I want to have only firewall enable, or I want to have only URL filtering enable. Not a problem, we can customize it. On the customization, you can say only URL filtering I want to configure. We can customize with only one security bundle included as part of the customized policies. So we can go back to the configuration tab, the place devices are whitelisted, certificates are updated, or the templates and then policies are created. In the same place, we have a new tab for security. By choosing the security, vManage will ask like which bundle and which bundle based configuration we are about to enforce it. Okay, so to give a detailed information about what it is available, so application aware firewall, how this application aware firewall on a WAN edges will filter the traffic, IPS from where the signature databases gets updated, URL filtering, whitelisted URL entries, and then blacklisted URL entries, and then DNS, and then web layer security information. So all the informations like how the devices functions and then what configurations are required, we will discuss about it. So the first concept as application aware firewall. So application aware firewall in the sense like we can create firewall policies, we can match source destination IP addresses, source destination port numbers, or we can match based on applications. So Office 365, Google application, Salesforce application, or any cloud-based applications we wanted to name, we will classify them. And once the applications are classified, and then we can define the way like in a Cisco ASA firewall or zone-based firewall logic, we create inside zone or inside outside. In ASA, we create inside and then outside. The similar way, we create zone 1 and then we name them as outside zone, and then zone number 2 and we name here as inside, and then zone guest and then we name it as the zone and then named as a guest. So outside zone normally connected to VPN 0 interfaces or VPN 0, and then inside zone connected with VPN 1 or VPN 2. One or two VPNs we can place them into inside zone, and then guest zone, the place where guest users are connected, and that particular specific VPN we can specify it here. So outside zone mapped with an VPN. Inside zone is mapped with one or two VPNs, and then guest VPN is mapped with one or two VPNs. So any traffic to go from one zone to another zone or one VPN to another VPN, then obviously these policies will play the role. From inside zone to outside zone, port number 443, port number 80 on TCP permitted, and port number 53 on UDP is permitted. So FTP, so 2021. So what port numbers and then protocol numbers are permitted? Or if you don't want to use the port number, we can tell application Office 365 is permitted from inside zone to outside zone. So we can determine application based policies or TCP UDP or TCP UDP or Ethernet related header information, we can use it. So Ethernet header or Ethernet frames like IP address, MAC address, sorry, IP address, port numbers, and then URL or the layer 7 information, we can include it. So one or more VPNs are mapped to a zone, intra-zone, inter-zone, and zone to DIA traffic policies. So intra-zone from VPN 1 to VPN 2 or VPN 1 to VPN 3, from one inside zone to guest zone or inside to out zone, or inter-zone, so same zone communication and then different zone communication. Zone to DIA, direct internet access, the place where direct internet connections are terminated. So it depends on that we can create our policies. So intra-zone and inter-zone traffic between multiple VPNs requires route leaking because we are trying to make inter-zone communication, VPN 1 to VPN 2 or VPN 1 to VPN 3. So in this situation, root leaking subnets should be reachable from one VPN to another VPNs. By default, WAN edges can classify 1400 plus layer 7 applications. So this is the current situation. It can classify 1400 plus layer 7 applications. If even any new applications are introduced, or if you want to customize as per our requirement, and we can do the customization for that as well. The application firewall, it blocks the traffic, passes the traffic, or inspect the traffic by application category, or whatever it may be the configurations we have mentioned. So zone-based firewall policy logic is introduced. VPNs are mapped inside the zone. Obviously, any traffic is going from one VPN to another VPN. Traffic will be permitted through the policies. And application-based classification and applications can be called into the ACL policies. Okay, so this is the first functionality and associated configuration as part of the application-aware firewall.
Okay, so intrazone is nothing but within the zone.
Yeah, intrazone is same zone. Yeah, same zone. Basically, in this picture, inside zone, we have VPN 1 and then VPN 2. So VPN 1, VPN 2 is inside the same zone. That is inside zone. If VPN want to talk to VPN 2, obviously root leaking is required. And even if you want to give policies towards to it, we can do that.
Okay, like if a VLAN 1 want to talk to VLAN 2, so both VLANs to be talked, so we need inter-VLAN routing. Similarly, like the route leaking is required.
Yes, yes, exactly.
Okay, okay. What is this 6-tuple matching?
6-tuple matching is based on source IP, destination IP, source port number, destination port number, protocol number, plus application. Means up to 6 entries, or up to we can match it, like one source IP, destination IP, protocol number, port number, or any other DHCP parameter. Like up to six matches, you can do it for one policy.
Okay.
So the configuration, I will show it in the device itself, but you can take a look here. We go back to the configuration on vManage. We choose security, and under the security, if we enable firewall policy will open the first box, and then it opens the second box, and between them, we will apply the policies. Sources. So we can create one zone here. For example, this is zone number 1, destination zone number 2. In zone number 1, I think I can do something here. So I can create this place zone number 1. And while we are creating zone number 1, this is like VPN 1 and then VPN 2. What VPN traffics are permitted here? And then I can create a DIA zone or zone number 2. I create zone number 2, and this is permitted with VPN 0. Okay, so displays any traffic coming from VPN 1 to VPN 0, from service VPN to the transport VPN or control transport side VPN. And here VPN 2 to the VPN 0. Then apply zone policies. So now between these two places, policies will be applied. What policies? This place we can determine our policies. This is the place where our policies will be created. So in our policy, we added new sequence rule. So while we are adding new sequence rule, this will tell you this is like ACL1. And in ACL1, you can tell what is going to be the source. So source will be the IP or the whatever may be the subnet, or we can specify the application, and then what is going to be the destination, and what is going to be the protocol. All the ACL specific conditions we can do it. If you want to have multiple ACLs to be matched, you can place it here also. Okay, so from VPN 1, VPN 2, that is zone number 1 to zone number 2, what traffic and then what rules will be permitted. So those configurations will be listed in this place. So like that, multiple conditions we can do, but this is applicable only between this zone to here. Then second policy we can create maybe zone number 3 to zone number 2, and we can place another conditions, another policies definition for these boxes. The first function as application aware routing policies or application aware firewall policies. The second option is IPS and IDS. WAN edges can act as the IDS IPS devices. Okay, and while we are enabling IPS features on the WAN edges, it's supposed to have the signature database. So it's supposed to have the local signature database, and any traffic coming from internet to internal or from internal to internet, it's supposed to be inspected against a local signature database. So by default, WAN edges signature databases are empty, and these signature databases are synchronized with signatures available from Talos. So this is like external signature database and supported by Cisco. And then Talos signature databases are downloaded into WAN edges signature databases. And once they are downloaded and once they are synchronized, any traffic comes in, and this traffic is inspected by comparing the signature database which is locally present. Okay, so we do see an option in a service container on Cisco ISR 4K routers and backed by global threat intelligence signatures and updated automatically. So inspects traffic in VPNs of interest. So any traffic in VPN 1, any traffic in VPN 2, any traffic in guest VPN. So VPNs you can map so that any traffic coming to the respective VPN will be inspected against the signature database of the managers. So three levels of signature set and the signature white label support, and it can run in deduction as well. So either we can enable IPS or we can enable IDS feature for this. So again, so under the configuration security, IPS intrusion prevention policy, the same logics will be followed here as well. So we will configure the targets. So target VPNs. So from where the traffic are going to be expected. So target VPN, and then this is going to be enable inspection mode. It's in the protection mode or it's in the deduction mode, and then signature set, and any log messages could be permitted. And signature set, what signature set it is going to validate, inspection mode, whether it is like protection mode or mode.
So the Snort IPS engine is a Snort and organization, Snort as well as this Talos.
No, Talos is an external server which is updated with IPS signatures like attack one. So attack one takes place through TCP and using maybe DDoS attack or DCP SYN flooding or whatever maybe like the mechanism. So each attack is determined with its unique signature, and universally available attacks and associated signature updated by Talos in its own database. When a new signature or when the signatures are updated into Talos, then Talos will update all WAN. So WAN-edge will have no signature database. It synchronizes from Talos, and then whatever the newly updated signatures are present in Talos, using that even IPS, the routers will try to the inbound traffic or the outbound traffic. Okay, so Talos is externally available. This is not available internally. Talos is externally available in the public network. So routers or WAN edges will talk to Talos server. Talos, it downloads all the signatures and in the local copy they will perform the IPS functions, or they will run with its unique IDS functions. All right.
Do we have any option to create security certificates for applications based?
We don't do anything with security certificates.
Okay.
And a third function we can enable as URL filtering. URL filtering, as we are familiar on the WAN edges, we can create a URL filtering database. And on the URL filtering database, whitelisted URLs and then blacklisted URLs. Once we create our entries based on that, if any connection comes for the URL, I mean, connecting to external URL, they will be matched against the local database, and they are permitted or denied, they will be decided. So runs in a service container on Cisco and ISR 4K routers, cloud lookup with local caching or a local lookup. So local lookup downloads URL database to the router, and 82 plus web categories with dynamic updates. So predetermined whitelisted, I mean predetermined listed web URLs are present, and they can be placed in. Normally, if you want to use it for your block listing, we can add them. Inspects traffic in VPNs of interest. Again, to monitor the traffic or for the URL filtering, this is inspecting the traffic from the VPN itself. Block based on web reputation score, and create custom black and whitelist, customizable end user notifications. So even we can create a block page once the URL is blocked, and a notification or a warning page will be written back to the end users as well. Okay, so it's like we don't have a new features, like whatever the existing firewalls, existing IPS, existing URL filtering devices and its related functionality. Those functions only will be allocated and then will be taken into the routing way. How these boxes function, similar to that, the features and then functions will function on the routers as well. In the configuration, so same place, one common place to enable all the policies. So under the configuration, we go with the security, URL security, URL filtering policy, target. So from this specific VPN, any traffic comes in, so they will be filtered from this specific VPN. And then we can say like action block page will be there, and then block list and then whitelist reputation category. So now we can see the policies over here. Policy role configuration, web categories in the block, and we can specify whatever the predetermined or pre-classified URLs blocked. Okay. And then whitelist URL list, we wanted to create some of the whitelisted entry, we can permit. Otherwise, only blocklisted entry. So these categories are found. The traffic will be written, or the user will be written with a block page. Other than that, everything will be permitted to the outside network. Okay, so similarly, we do have DNS and web layer security. In case of DNS and web layer security, every DNS message, DNS query, and then DNS response will be validated. Whether this DNS query is a standard DNS query or any modified or any infected contents are available in the queries and then responses. Similarly, for HTTP or any kind of application traffic, the contents are properly available or any modified contents are available. So cloud only DNS based inspection. Now this is supports with the DNS based inspection, like all DNS queries and then DNS responses. Basically DNS responses and DNS queries from the client side will be inspected, and API key registration. So it could be registered with external servers like Cisco Umbrella, and VPN aware policies, global points of presence, and Cinecast IP for fastest response and then high availability. DNS script, basically encrypted DNS communication, local domain bypass, and intelligent proxy structure supported. Okay. So same configuration, like we do have the target VPN permitted if it is any local domain, and then local domain information, so that a local domain URL will be permitted or will be bypassed. And apart from that, what VPN it's permitted, and any DNS query comes from the VPN to where it's supposed to be redirected. So DNS server, it's Umbrella by default. So Cisco Umbrella server. So to Cisco Umbrella, all DNS queries are forwarded, and Cisco umbrella will verify whether this DNS query is a proper one or this is having any content which is like modified. Okay, so registration umbrella defaults. So we need to have umbrella subscription with Cisco. Then only these DNS or web layer security functions we can provision it. So umbrella registration we need to finish. And once this is done, then we can be able to send all of our DNS query to Cisco umbrella itself. Okay, now we don't want to send it to Cisco umbrella for DNS communication. We wanted to use our internal DNS server. So custom DNS server we wanted to enable. We can enable custom DNS IP address, but this custom DNS or the local DNS server should be capable for DNS or web layer security functions.
Before this, can you just little bit brief about what exactly umbrella is and how it works?
Yeah. I think there is a picture is available. I will tell about here.
Okay.
AMP, advanced malware protection. It's basically for file scanning any data which is communicated over the network, and this data will be scanned. And then even you wanted to keep a track like what files are scanned and then what files are communicated, and AMP functions will do that. So file a reputation check powered by Talos. The sandboxing and file analysis for unknown signatures provided powered by the threat grid. Automated signature update from threat grid to Talos and inspects traffics in VPN, and it leverages Snort engine to identify file transfer. So any file communicated over the network connections, obviously they are checked and then they are validated. So AMP configuration, advanced malware protection. So again, target we try to specify, and then we do specify the policy condition. So what traffic and then what configurations, what file we are going to inspect and from where we are going to integrate it. Okay, so here we do have an option for DNS security. So how it functions. Suppose we have an end user connected in the internal network. So end user connected here in the internal network using private IP address, and this user is about to access the servers available on the public network, maybe the web servers. So web client and then a web server. Before the communication takes place from web server to the web client to the web server, and users will try to resolve the name from fully qualified domain name to IP address. So the first message comes out from the end user will be DNS request. So on the DNS request, the URL or the fully qualified domain name is mentioned, like www.ibm.com. So this fully qualified domain name should be resolved into IP address. If it's a genuine user, a normal DNS query will come, and on the normal DNS query, fully qualified domain name will be present, or domain name will be present, and we'll be expecting the answer. We'll be expecting this name is available with what kind of IP addresses. If it is a modified one or it is updated with some kind of for example fields in the DNS, okay, normal devices, normal server, normal client, normal routers will not be able to identify them. So DNS kind of hacking or DNS kind of inspection, we can do it with the help of Cisco umbrella server itself. What Cisco umbrella server does, if anybody is sending the DNS query, and Cisco umbrella will receive them, and it will read each and every content on layer 7 of DNS query. Okay, this DNS query, every option is available in the standard format, or any codes or any scripts or any malfunction informations are available over here. If Cisco umbrella sees it's a standard query, will give the response as permit the query. If umbrella finds that something is vulnerable, then Cisco umbrella will say that this is an malfunction frame or malfunction data that's supposed to be blocked. So Cisco umbrella will validate the DNS query is the genuine one or the DNS query misconfiguration issues. So now what happened? End user trying to access the web server sends the DNS query. It reaches the VAN edge. Okay, if you don't enable the DNS or web layer security, WAN edges will read them, will look for source destination IP address. Based on the destination IP, they will forward to the internet, and then it goes to the internet DNS servers. Once this is enabled with DNS and then web-based security, instead of sending them to the internet, okay, these DNS query messages are redirected to Cisco umbrella server. Now this Cisco umbrella server will receive the DNS query and validate them, and will just say that this is kind of a genuine request. This can be permitted to public network. Now, based on the permission from the Cisco umbrella, devices will understand it's a genuine query. So whatever the DNS query comes in, they will be permitted to public network. Okay, and whatever it may be the response, and then request for HTTP communication, they will be communicated. So any DNS query to be permitted to the outside network, whether to be permitted or whether to be denied, the decision managers will take with the help of Cisco umbrella. Okay, so there is no secret or no new concept involved over here. This is like external authentication. We have TACAX authentication or radius authentication. User is trying to log in into routers. Users are logging into a firewall or any kind of networking device. Instead of they are validating the username and password local, these username and passwords are redirected to the place where TACAX servers or radius servers or AD servers are available, and these servers are available with the local database and local intelligence. By checking the username and then password, they will say that whether these users are allowed to connect with the router or firewalls or this kind of networking devices. That means the devices will take the decision based on the external devices. The same behavior is followed here as well. Users are sending the DNS query to internet. Routers are going to intercept. When they intercept the DNS query, they are forwarded to umbrella servers or external DNS servers, and umbrella or external DNS servers will validate them. If they are genuine, if they are valid and then standard DNS queries, they will tell the routers to forward to public network. If umbrella is finding that something is vulnerable, then it will suggest the WAN edge router to drop instead of forwarding them into internet network.
And what if the end users, I mean, now if you see at this situation, everyone is working from home only.
Mm.
So if you want to go and access the internet when you are at office, so your managers are capable enough, and it talks to the external DNS service which is hosted on Cisco umbrella. So based on the Cisco umbrella, it will decide whether that DNS query has to be dropped or it has to be allowed. When we are at home and we would be using the home broadband, so in that case, how the data will be exposed or protected?
No, you cannot do that. That's why we introducing compliance.
Mm-hmm.
Okay, if you are enabling the compliance, now what happen? Even though you are having local internet or local broadband, if client wants to browse to internet, it will come through the VPN tunnel to their data center. From there, they will be taken to the outside network. So if PCI compliance is enabled, then you can do this kind of security checking. If this is not with the PCI compliance, local internet is allowed for your clients on the VPN. Obviously, you cannot control it.
Okay, so you mean to say that, for example, I would be using, see, every organization would be giving a work from home option, so they would be giving some client VPN to install locally in their machines, the laptops or whatever if it is. So that would be provided to access the office network. Okay, so
Hmm.
to come to office and to access the resources which is there in our enterprise organization. Okay. So now if I want that to be for internet, I use my home broadband. So whatever currently how this, I mean, I'm just considering telling you a situation with umbrella and without an umbrella. Okay. So now today I'm at home broadband. If I want to access any internet space destinations, my internet traffic will go from my service provider network itself. Only in case if anything, if my destination is anything specific to the enterprise network, then I'll establish that particular data will go to on this particular client VPN in the tunnel. It will go and reach to office premises. So that's way it is. So here, if we integrate umbrella, so I mean, so where exactly we have to integrate the umbrella here and how it happens? I see an organization is telling that even though your client network is reachable through public internet, which I don't want, so it needs to be secured. So where do we have to actually deploy umbrella?
No, no, you cannot implement. This is for end users like VPN clients, the users working from home
Yeah.
when they are available with local internet connections. It is not supported. Suppose if there is a situation, these users are having PCI compliance, all the internet traffic for these clients coming to the data center vantage. From there, they are taken into the route to the public network. Then, in that case, data center routers can be enabled with Cisco umbrella integration. From there, you can control it. Until
So
as long
oh,
as the clients are available with local internet, you cannot implement umbrella and you cannot ensure the security.
okay. So once my umbrella, my client VPN is integrated with Cisco umbrella. So my internet traffic also will be get through. I mean, will that also get inspected, or
Yeah,
only?
that can be, but that concept will go as a different because clients are having a Cisco VPN client, right? So VPN
Yeah.
client to Cisco umbrella integration is a security different task, not with this SD-WAN task.
Okay. Okay. No, generally I'm asking. I mean, Cisco umbrella is it's
Yeah,
like yeah.
yeah, you can do that. If the VPN client is receiving any DNS query to be forwarded over the local connection, obviously before this is forwarded, it can intercept and it can send it to the umbrella directly. And then based on the response from umbrella, clients can take a decision whether it can be forwarded or it could be like dropped.
Yeah, because why I'm saying is, seeing now in my organization, umbrella is integrated with my client VPN. Okay, so the moment I connect to my office VPN, it says umbrella is active. So, but umbrella, Cisco umbrella is mainly for it's for the DNS to see whether the reliable information, whether we are accessing the right sites or not, whether it has to be allowed or not. So, but how do I know whether all my internet traffic is passing through Cisco umbrella or not?
With the clients, it's very difficult to manage. With SD-WAN, if you are integrating, then you can see a logs and then you can see a alert messages. Based on that, you can be able to notify that. But without SD-WAN, WAN edge devices communication, again, VPN clients should generate the local database or local configuration base or local log base. From there only, they can put all the details in it.
Do you know what is the external range for the Cisco umbrella DNS servers?
So just give an Cisco umbrella. They will take automatic communication with. Because there will be a standard DNS query. This will go to Cisco umbrella server. They will communicate. That's the way device.cisco.com available. Similar way like standard umbrella and Cisco DNS query will be generated.
Okay, okay, fine, okay, got it.
Yeah.
Okay.
Yeah. So these are all the security features. Features supported across the WAN edges, enabling application-aware firewall, IPS, AMP, DN, DNS, and then web layer security, plus URL filtering. Now, what hardware and what features we are allowed to enable? If it is VH, viptela 100,000, 2,000, and then 5,000. IPS and then URL filterings are not supported over here. Even ASR 1K, 1001HX, 2HX, and then 1001X, and then 1002X. Okay, so these boxes won't support with IPS and then URL. Apart from that, Cisco CSR 1KV and on ENCS ISR virtual, ISR 4K, ISR 1K. So these boxes will be supported with all the features like firewall. We can enable application aware firewall, IPS, URL filtering, and DNS or the web layer security. So we need to obtain additional license to enable the security bundles. The option here you can see this DNA Essentials along with the standard license to run with the fabric or to run the fabric. On top of the standard licenses, you can have a DNA Essentials. By enabling DNA Essentials, so security bundles, enterprise firewall, application aware firewall, IPS, URL filtering, DNS or web layer security or DNS layer security monitoring, we can enable. If you have a DNA Advantage license along with security, cloud-based option also we can do. So cloud application discovery and advanced SD-WAN topology, like various topology like point-to-point and hub and spoke, full mesh, partial mesh. Okay, this kind of different topologies for VPN could be supported. So it depends, like essentials license only with the security or advantage license with both security and then cloud-based application visibilities.
So this DNA essentials and DNA advantages is nothing but the SD access.
You cannot say that, but it's a license name. So DNA essentials and then DNA advantage is a license name. Can be integrated with SD-WAN.
Okay.
So we need Cisco umbrella subscription for enforcement because DNS layer security comes in. So obviously umbrella integration has to be in place. For the Cisco umbrella integration, obviously that subscription with Cisco is mandatory.
Okay.
Right. So this is the points as part of the SD-WAN security I would just want to cover, and then configurations we can do it.
Oh, can we have 15 minutes? I mean, break and come back in between.
Yeah, sure. I think now
How do
it's
you guys? Murugan, Pavan, 15 minutes. Venkat, Vishal, is it fine now? We can just go to a break and come. Right.
Yes, correct. Yeah.
Okay. Okay.
Okay, so we do see the dashboard and then monitor configuration. As part of the configuration, devices.
Parthiban, 1 second. Do we have everybody? Rudresha, Naveen, Venkat, Vishal, Murugan?
Okay, so all SD-WAN configurations goes under the configuration tab. So devices for whitelisting, TLS SSL, it's for proxy communication, certificate, templates, policies, and then security. So this is a place security policies or security features towards to the end devices gets created. So now by default, no policies. We can add the security policy in the dashboard. I mean, in the wizard manner. Okay, or if we are familiar with CLI and then custom option, we can create the policies. So like firewall policy alone or IPS policy alone, URL filtering, AMP, DNS security, TLS or SSL decryption, and then umbrella registration and then threat grade AP. So these two are like umbrella registration functionalities, but security wise, firewall, IPS, URL filtering, DNS and AMP, TLS and then SSL decryptions. So now we will try to customize them. I go back to add security policy. This is a default bundles suggested from Cisco: compliance, application, firewall, IPS, and then SSL decryption, guest access, application, firewall, URL filtering, and then decryption, direct cloud access, direct internet access, or custom configuration. Suppose if we try to choose compliance, so we wanted to enable compliance for the network. Select the compliance and proceed. So now we can be able to see two options. So we are allowed to create firewall policies, and we are allowed to configure the IPS policies and then TLS or SSL decryption. Now these three policies will be enforced under security policy. So one security policy will have three policy and then associated configuration. If you want to include, we can include, or we can bypass, we can do that. Suppose a firewall policy. Now I can say add a firewall policy. We are creating the new firewall policy. As I told you, it's a zone and then a source zone and then destination zone. Apply a zone pass. Now there is no zone by default present. We can create it. So select a source zone. So nothing is available. We can create one zone here. For example, zone number 1. Or inside zone. Inside zone, and inside VPN is 1. And then you can choose inside zone. You can create the destination. This is like transport zone. Give it the VPN ID of 0. Now we can choose. This is like a transport zone. Let me. So any traffic going from VPN 1 to VPN 0 will be filtered using these firewall policies. So what traffic we are about to permit. So now we can find match and then action. So this is the policy name. This is ACL 1. Then I can keep ACL 1. Add rule number 1. Okay. So now source prefix, source port number, destination prefix, destination port, protocol. If it is needed, any application, you can define with the applications. So any application going from VPN 1 to VPN 0, or any traffic going from VPN 1 to public network. And what is the action we are about to do? Whether we are going to inspect, or we are going to pass, or we are going to drop, or we want to enable the log for it. Let's say I'm enabling rule number 1. So this is going to pass the traffic, and I'm going to log it. And the source data can be anything. Source port number can be anything. Destination, I will add one prefix. So if it is needed, you can create with the prefix list if it is defined already through the normal policies, or we can add the subnet here. Let's say 25.0.0.0/24. And then protocol. So we can have the standard protocols over here. So TCP, UDP, ICMP, whatever it may be, like say MySQL. And then I can save it. So we can find one policy. So order 1, rule number is 1, our rule name is 1. We will pass the traffic, and log is enabled from any source to any source port number. I mean from any source port number, yes, any source IP address. And then we do have an option of destination IP address, destination port number, and this particular protocol we are permitting it. Okay, so one policy, and then default action is drop. We wanted to add more policies and then more access list, we can define it. For example, application list. For example, list one, and I can choose the application. Let's say Office. The Microsoft Office application. So Google Play, Google Talk, Google Chat, Google Services, downloads. So like whatever the things we wanted to permit, we can include it here and save it. We can choose list number one. So using this is the applications permitted. So list one which contains, and so we are going to pass this and we enable. If it is needed, rule name we wanted to modify, we can do, and you want to place on top of that, and whatever it may be the sequence, we can include it.
So, Parthiban, here, we have allowed only few applications, right?
Yeah.
In case if someone is trying to access something which is not allowed, okay, and if they, if they start trying many times, the traffic will start dropping here. Is there any mechanism to see what all are tried and which is stopped? You know, I mean, like I can see in log, but apart from that, is there any way that it can keep throwing alerts to, say, a list of users or that kind of provisions do we have?
That you can test it through device monitoring only. Maybe you can go, suppose if you want to check across Vantage one, what traffic is permitted and then what logs are generated or what is inspected. So those security content you can verify for a router level. We can go to the vManage itself. From the vManage, you can check them one by one. For an example, I can save the policy. You can go to the device monitoring. From here, I will show you. Just give me a minute and then I will show you that. So I will enable one policy for testing
Sure,
purpose.
sure.
I save this policy. Okay. Now we want to add more policy towards to it. We can add it. If not, we can go to this and IPS. Now IPS policy, create a new IPS policy, target VPN, and I want to enable IPS inspection for VPN 1. Okay. And then the policy name. This is IPS policy 1. So this is available on the inspection mode or the direction mode or the prevention mode. We'll make it in the production mode. And signature set is security. And then we can save this configuration. Okay, so for firewall IPS policies and then firewall policy both are available. And then next, if it is needed, TLS and then SSL decryption. So configure your TLS SSL decryption policy for added security, inspection of traffic, deeper security instance. So in this case, devices, these WAN edges will do decryption of the devices and then they will try to encrypt it. Okay, so this is the security policy name. This is like a security policy 1. Okay, so everywhere the policy syntax is the same thing. Even our centralized policy, we create centralized policy. In it, we will include data policy, control policy, AR policy. Same way, security policy, in security policy, firewall policy, IPS policy, and then AMP policies or DNS or URL filtering policies. Okay, so now this is like a policy name, and then preview. The same format the commands also would be generated. So policy, intrusion prevention, this is the policy name. Security level security, and inspection mode is protection. Log level is error. Target VPNs. In VPN 1, the traffic will be inspected. The zone-based firewalls, we created ACL1, destination port number, so destination subnet and then destination port number, and then protocol, and then protocol application name. And we are going to permit and we log it. Then VPN 1 in inside zone, VPN 0 in transport zone, and then zone pair to permit the traffic from VPN 1 to VPN 0. So source zone inside and then destination zone and zone policy ACL. Any traffic going from zone 1 to zone 0, this policy will be applied. This is like a syntax you can see. Okay, so in the GUI, we do create and then policies associated commands are generated. Now these commands will be enforced to all the WAN edges. While we log in into WAN edges, we can be able to observe this is available. So preview command will tell you these configurations. Then show sd-wan and policy. So access list names and then restart data policies and other policies access list names. Increase. So sd-wan configuration. Security policy 1 and this is enabled. There is no command to activate like this. So to just monitor, you can go to monitor or devices network. Anywhere you can go. So we manage, we bound branches. You can choose any one of the device. This is a monitor dashboard. So whether you go through monitor or real time, anywhere the same dashboard will be open. From here, you can check all of our configuration. For example, Tls Tunnel, okay, security monitoring. So this is the place you can observe all of our security configuration. So firewall, IPS. So firewall we enable, IPS we enable, and these features we did not enable it. And it's supposed to enforce the policy. It's not displaying. That's what even I'm trying to check. Once this is pushing the, once vManage is pushing the policies, and obviously we can be able to select one policy is available or one policy is created. It shows policy 1, source zones as destination zone, and sequence count, number of bytes transferred, and then number of bytes are transmitted. So data information also you can be able to check. Plus logs will be generated in these places. Okay, so this log is present for what in how till how long this has come. So IPS by severity, by count, and then IPS related informations you can be able to verify. So this is not enabled. Let me check why this policy is not enforced. Go back to the network. We'll try to choose branch V2. In all the devices, we can see the same format, security monitoring. This policy is not an impact, so I will try to delete and then I will create once. Go back to security. or else, or else we wanted to add it through the template also we can do. But I don't think so. I have got a feature-based template for any devices. I can go to the devices. Then templates. So branch C3, I will have branch C4 and also 5 and then 6 with 2 devices. Okay, I will try to edit in this place. Edit. Additional template. So security policy. I will enforce the security policy. Security policy 1, and then I will update. And error is giving with everybody. Based firewall. There is no requirement to place everybody because I have placed IPS also. Needed policy summary. Template. Right. Let's move. I will create one dummy entry in this one. SSL decryption design certification authority. Manage SDA. I'll do one thing. I will try to create simple policy and then I will try to enforce. Then I will go with this bundle. Security. Delete. I go with custom option. Firewall policy. Add policy. And then I go with custom and then proceed. Add firewall policy with create new. supply zone, inside zone, transport zone, and at the first row. Passing a log source data is 36 or 36, 36, 36. That's 32. And destination data prefix, which is 39, 39, 39, 39 slash 32. I'm giving an exact addresses. Save.
These are all the loopbacks which we created, right? I mean,
Loopback on branch V1 and loopback on VM10.
okay.
So I'm just passing the traffic and I'm enabling the log. All the protocols, any protocol, any applications will be permitted. Let me save this and saving the firewall policy. So next, IPS not needed and URL filtering not required, and AMP, DNS security, TLS, and this is security policy 1, policy new. So I'll just give this security policy new and then policy. So zone based policy ACL1. I'm permitting from this source IP to this destination IP permitting, and other than that, everything is denied. Inside zone, outside zone, zone pair is also configured. Zone 2, no zone is denied. That's fine. And then save policy. Policy is created, and then I go back to template. So 5, I edit additional template. Security, security new update. All required place must be configured. This is not mandatory to enable all the configurations in it. I don't know why this is creating. I need to fix and I need to with this image. So why this is not allowing the security policy? But let me give it a try once. Okay, so Cisco security with SD-WAN and umbrella integration process. So for this lab, I downloaded the lab associated with this lab limitations and so umbrella tunnel auto provisioning. So you can read one by one and what task we are about to go for it. Okay. So on the topology, so these devices are present. So DCVH1 and DCVH2. There are some data center devices, MPLS and then internet-based transport. branch number 1 and then branch number 2. So there are like branch 1 CH1, branch 1 CH2. So data center V edges, branch 1 C edges, and then branch 2 V edges. Okay, so there are like Cisco boxes, and then there are some viptela boxes. Over the internet transport, we manage vSmart, Cisco Umbrella, and then in vBond. The Cisco Umbrella server is connected on the public network. So this we manage and configuration related to the security and umbrella integration we try to do. Based on that, security policies or the policy configurations will be enforced from we manage to the end devices. So scenario, umbrella tunnel auto provisioning, normally the registration process. So integration process between SD-WAN with umbrella, so that Cisco will come to know like customer 1 we manage or customer 2 we manage gets integrated with Cisco's umbrella. So we'll go with step by step. So D cloud lab topology, we connect with RDP workstation and then IP address. Okay, so branch to VPN 10 Win10 workstation and connected to LAN for the testing. And we use Windows 10 to open Firefox and then Umbrella test. So this is the place where we are going to take all of our connection. And then create Umbrella Management API programmability layer interface keys. So any communication takes place from vManage to Umbrella and vice versa, or the end devices to the Umbrella devices. Nowadays, it's programmability layer access, so API communication connections towards to it. Browse Cisco Umbrella, and then we try to see the options, deployment health. So the dashboards in Cisco Umbrella, whatever it is available, we can find. So dcloud, SD-WAN, and user 103. This option you can see it, and we create an API key, and this API key will be down installed through the vManage itself. So I will do it this better, but we can see like what are umbrella and then to enable with vManage. So create viptela secure internet gateway. So SIG. So this SIG configuration. So interface name. So we create one logical or tunnel interface and physical port for this communication path. And we will enable them. If it is a secondary path, secondary tunnel also, we can place it. That means we establish the connection from any one of the device into in this example, branch type 2, I think branch 2, they are going to talk to umbrella for these um, packet data transmissions. So we need to modify transport and then VPN configurations, and then web umbrella associated configurations, we try to add it. Then service VPN routing. So basic VPN configuration 2, 3, 4. What testing we are about to do, this will be connected here. And then we check whether the tunnel is created from this Vantage to Cisco Umbrella. So to pass all of your query messages. So we check with network tunnels and then active tunnels. And same way, like even in the device. So using vManage, we go back to the specific device. In this device, we try to check whether the tunnel is created between Vantage and the Cisco Umbrella. Then we do create policies. So here we create a firewall policy, and then in firewall policy we will apply or we what TCP and then UDP port number to be. Okay, so policies and then management policies and application settings, we can set them, and we can traffic we initiate from one end device. This will be like a permitted or not permitted. We are blocking it. Obviously, this traffic will get denied. So this is the process. We are going to test it. Cisco Umbrella integration, and top of that one policy from Umbrella. Based on that, whether this is permitted or not permitted, we do test it. So let me configure this for you one by one. I will connect with the workstation. This is the workstation, and click it. remote desktop. So we are into this RDP, and RDP will start with branch 2. We open the Firefox. Umbrella text. Let's use the best shortcut. RDP, inside RDP, another RDP. So this is the student P branch 2 VPN 10 Windows 10. We don't have any names inside that. We are connected to it. On this machine, we open the Firefox. We do have called umbrella test. We click on it. Okay, so this device is not using umbrella. This is fine. Being used. Facebook and then port test. The outgoing port tester. Now this is opening it. IP check 178.38.218 and then 6. Is not using umbrella, so all the traffics are permitted. This is just they wanted to highlight before the configurations we try to do. So use the port 44 test and then Facebook bookmarks to further demonstrate that there are no policies being applied to the traffic. They are permitted by default. And close this RDP and close or minimize. So close this testing PC, what they wanted to give it here. Okay, so now from the dcloud topology page, remote desktop and then workstation 1 and open another. Yeah, so we open the workstation and then on top of that we have umbrella. So using umbrella admin dashboard, we will log in over here. Let's see whether it is prompting for username and then password. Cisco umbrella login. It's not prompted for any username and then password. So this is like a deployment policies, investigate. So this is umbrella configuration and also can be maintained at Cisco as well. opened it. So once logged into the umbrella dashboard, you will be taken to overview page, general message are displayed, and so many other things. So for the first step between the integration step between umbrella and viptela, we do create a key and secret for the umbrella management API. For the communication between vmanage and umbrella, it's like a common key or common protected access. So wherever, like even if you think about the TACAX or the radius AAA authentication process, we do maintain a common key between routers and then the TACAX or the radius server. So any further credential communication takes place, they will get encrypted. A similar way, for the protection, we maintain a common key or the password or the secret password between umbrella and vmanage. Using that, the secured communication takes place. So we go back or we go to the admin and then API keys, create the API key button and select umbrella management, and then we do select this option. So we go with admin. Okay, so decloud sd-wan user 301. We go with admin tab. So under that, so API keys and create API key. So API keys. So you have not generated any API keys, create the API key. So what should this API do? This is for umbrella device or network devices and legacy network devices, umbrella reporting or umbrella management. So this is selected for umbrella management, and then we do create it. And then we create. Okay, so there are two keys generated. So the key and your secret. To keep it secure, we only display the secret. Okay, so we copy the organization ID from the URL and Notepad Plus. I go back to here. On the URL, we do see the organization ID. Copy and then Notepad Plus. Paste it. Copy and paste it. So we copy the organization ID from the URL and we copy to Notepad, and it's a 7-digit number that's represents Cisco umbrella account with your decloud. Okay, the same account ID will be provided to the customer as well. We can use and then we can connect with it. Okay, so now this is the step we did it through umbrella. Any questions or any clarifications required what we are trying to do at umbrella? We are trying to do the integration between umbrella and vmanage. For the secure communication between vmanage and then umbrella, we need to maintain a key. So instead of as a user, we are selecting our own keys. So umbrella generates the key and same key will be presented from vmanage itself. That's what we are trying to do that. In a legacy designs or in the legacy network, we maintain a common key. We will assign on device number one. On the destination device also, we will try to map it. But here, umbrella creates the key, and this key will be used by, or this key is applied through vmanage. So we go to the viptela. So basically like viptela we manage, and we log in over here. We go to the template. Under the features, we add a new feature template, and we are selecting VH Cloud, and then template name description with organization ID, key, and the notepad information. We are just creating a template. In the template, we are placing organization ID, key, and then the patients. So what I will do, I go back to vmanage, I minimize umbrella and open the Chrome, go to vmanage. Admin and admin, we logged in. There are again same scenario, 1 vmanage, 2 vbond, 2 vsmart, and 5 manages. Go back to configuration and then templates. Okay, so we go back to the feature templates. We will create a new feature template, and we choose it for VH Cloud. Okay, so this is what prompting. So we go to the feature and then add a template, and then we choose the VH Cloud, and under the other templates, we click SIG credentials. We don't do anything under the template basic information, VPN information, other templates. Under the other templates, SIG credentials, we choose it here, and then template name, description, organization ID. I will create a new name for this. So SIG template umbrella to manage or manage. And then basic details. So secure internet gateway provider is umbrella. Organization ID, it is like global. We can copy the one, paste it here, and then registration key. Here, then the secret. Yes. So we apply the organization ID, key, secret from notepad into respective, and point out get keys, and how customers that buy DNA Premier click get keys to have of instance save this. So now let's see, get keys. Not account is not found. Save it. So SIG umbrella, and this is great. And then we create one more template. So we create add a template on the new feature template, VH Cloud, and under the VPN, we will choose internet gateway, I mean secure gateway interface. Then we will create this is with a tunnel. So interface name and a physical port and configurations. So we will build the VPN WAN, the one which we are trying to select, physical port to the umbrella. For that, a new feature template. I will create this, add templates, VH. VH Cloud under the VPN. So we can find the secure internet gateway. So this is the uh, object, or which is the template we are about to configure, secure internet gateway. Gateway configuration to it. The template name, this is SIG interface tunnel. And then under the configuration, we now add the tunnel. Add the tunnel. So tunnel interface name, they are interface name is Ipsec, and the physical port. So we need to give G0/0 source interface G0/0 is a physical port for umbrella, and then is primary. So add tunnel interface name I created, physical port. We need to add this. This is primary. Add. I will add with Ipsec1. Add the first tunnel Ipsec1, and they are asking us to generate the secondary. Two secondary with the same thing. Ipsec2 GE0/0, and then secondary. There are two tunnels from this device to umbrella, and then add. There are two tunnels. One is primary and then secondary. We created to Cisco umbrella, and under high availability, select Ipsec1 active, and then Ipsec2 is a backup. So active is Ipsec1, backup is Ipsec2. The feature template we created, and we can save this. Okay, so now you can see there are two templates, two feature templates I created. First feature template with the organization ID, key and secret. The second feature template is creating the VPN tunnel from VPN 0 interface towards to Cisco umbrella. and the physical port and physical IP address, primary tunnel, and then secondary tunnel information we just provided it. Given in this place. Now we will apply this feature template to device template. Now there is a device template already created, and this is mapped to one of the device. For example, they are asking branch type 2 template VH. So there you can find the branch type 2 VH. This is mapped with one device. So I think this device is going to form the umbrella secure tunnel, and then in these devices, whatever the policy we try to create, so through Cisco umbrella, it gets validated. So we go back to the device, and then we just go to this template, and then we will try to modify this device's configuration, one which we updated. So what I can do, we back to the device template. We see branch type 2 template VH. So this is the one VH cloud we have modified. One device is connected, and this is branch to VH1. So as per the topology or as per the lab guide, branch to VH. So this is the device. Go back. This is 9th page. Branch to VH1. So this device is going to, it has got two physical port. Using this physical port talking to internet. So from here, it forms first tunnel to umbrella, then second tunnel to umbrella. So active and then standby. So using the active or the standby, using the active, it forms a VPN tunnel umbrella with Cisco umbrella. Now this is the mapping we are about to do that. So these two port configurations are done under VPN 0. We are going to have one more SIG VPN interface, which is going to form the VPN tunnel to Cisco umbrella. So this branch 2 router with VH1, these configurations, we will try to do it now. So this device is going to form the active VPN tunnel with Cisco umbrella. This template I will modify it now. Go to page number 9. So I go to the template, which is device. Close here. So branch type 2 template. Edit this template. Okay, so we go back to the transport and then management. So there are two VPN interfaces. So one is going to go to internet, another one is going to go to MPLS. And over the internet port, we will add the secure internet gateways. We'll edit. So this is like branch to internet and then branch MPLS TLOC. So branch MPLS TLOC. So we will add secure internet gateway, and we will try to include the feature template on top of that. Select secure internet gateway, and here we will try to the template what we created. So here template we created, we will update, and then under additional template, credentials to form the VPN tunnel with the umbrella. So this is done, and then additional templates. So SIG credentials, we can choose, this is the template umbrella SIG, will map with it. Then we can update it. This update. So credentials under additional tab, and VPN tunnel interface under VPN 0 physical port. And next, click configure devices. Next, we can choose, or we can apply configure devices. The way like DTLS or control plane tunnels are established from Vantage to other controller, we manually establish IPsec based tunnel to Cisco umbrella. So any communication takes place from WAN edges with Cisco umbrella in the form of encrypted. So WAN edges encrypts, Cisco umbrella decrypts, and vice versa for any DNS or any policy and its requested communications. Even if I open the security, we talked about this picture. So here you can see and what is going on over here. So Vantage and then Cisco umbrella. Now Vantage and then Cisco umbrella, they are going to make encrypted communication. So plain DNS request comes. So Vantage, okay, encrypts it. So encrypted DNS request to umbrella, and umbrella validates and then gives the encrypted DNS response. So now this encrypted request and then encrypted response communication will happen into the tunnel what we try to build it. So inside the VPN tunnel, encrypted DNS and then encrypted DNS responses are communicated. Just to make this encrypted communication, this tunnel we made it. So in the first step, so what we did is we created and secure keys, the API keys we generated, and these API keys are used at WAN edges. So same API keys, and using these API keys, these devices forms the secure tunnel, and this tunnel is supported over the IPsec. So IPsec tunnel between these two devices we build it. So one physical port, two tunnels we have built it. So that's logics we built it. In a real-time scenario, if the WAN edge is available with two internet circuits, so one internet circuit through the direct internet connection, and another one is through the mobile network or through 3G or 4G network. So we can build first tunnel to go with physical port number one using IPsec, and second tunnel to go with a different physical port or which is talking to the 4G network, and then between them we can tell which is going to be the primary or which is going to be the active tunnel and which will be the standby tunnels. So this is the configuration up to now we have done it. So we just made an integration process between them, and then we made an VPN tunnel between these devices. And now it shows a success. The templates are enforced, and then we can see the tunnels are created. So navigate back to the feature template and configuration templates and then feature, and there will be a default gateway. Search for branch to VPN 10 and template list, and inside the template more options. We will create a new default route. So default route prefix and then click subnet. There is a default route placed inside. Select branch to VPN 10 features. We edit under service route, new service route. So we will install a new default route in it. So that's what it is showing. I go this configuration and then templates. Then under the feature, we should search for branch to VPN 10, branch to VPN 10. This is the template we need to modify, and then we edit under the IP service routes, service VPN routes. We add a new service route. Prefix is 0, 0 dot plus 0 default route. Now we will add this. So services would be SIG. There is a default gateway or default route presented through SIG interfaces. Then this is it. Then we can verify the tunnel created between umbrella and the VH. Verify the tunnel creation in umbrella dashboard. So we go back to umbrella under deployment, core identities, and network tunnel. So this machine. We go back to the other dashboard, umbrella. So under deployments and the core identities, we can check with network tunnels. So 2 tunnels and then 2 data center locations. So verify the tunnels that are listed in the active. There are 2 active tunnels. We can find IP security 1 and then IP security 2. So using this site 400 and site 400 viptela edge. I think as per the design, the branch to VH belong to site 400. So this is viptela VH. Tunnel is active. Tunnel and then a data center location. So using what public IP address? So now both are connected through same public IP address 218.161 because we made this is the active and then standby connection. Both the links are connected, but one will have the complete traffic IPsec 1. So both the tunnel source and then tunnel destination. Tunnel source will be the same IP address. So here in Cisco umbrella, we can check there is a tunnel up and then running. In the same way, we can check with other and also. So here from this page, you can find. So we have the site ID 400 and then system IP address for this device is 1040.1. So using this 1040.1, this has generated its unique identity. Okay, so here what they mean to say, when this is created with this ID, so site 400 system IP address for the device is 1040.1 and their IPsec tunnel number 1. The site ID 400 system IP 10.4.01 and then IPsec tunnel number 2. So here inside each tunnel, we can find the public IP address and then when this is created. So the tunnel ID and update tunnel ID. So the tunnel status about it. So Europe and then active tunnel public IP address and this is active just now. Okay, so we can just check whatever the tunnel is present on these devices. So they're like device number 1, I mean tunnel number 1, tunnel number 2 from one VH it get created. Okay. Any questions or any clarifications up to this place?
Any questions, guys? Murugan, Pawan, Vishal, Venkat. Vishal, Venkat. Any questions, guys?
Okay, in the same way, we can verify the tunnel from vManage. Through vManage, we choose the device. So branch to VH1 and then number of VPN tunnels available, you can validate it. Even show IPsec inbound and then outbound connection also will show. In the GUI also, we can be able to validate it. I go back to this devices. Under the devices, okay, you can go to monitor and then network. we can find branch 2v edge 1. This is the device. So all interfaces and then tunnel specific. So on the WAN interface, tunnel. So here also we can check and interface. So under the tunnel or under the interface. So IP security 1, IP security 2. These two IPsec tunnels are admin status and then operational status is brought up. This is like pointing towards to the SIG Cisco umbrella. So we can find these two tunnels plus additionally like from physical interface to different physical interface, color gold, color silver, whatever it may be, the tunnel which is permitted. So umbrella has two tunnels to this vantage and vantage has these two tunnels towards to umbrella. Now on the next step, now vantage and Cisco umbrella got integrated. Now we will define a policy. Based on the policy, vantages will receive the traffic from the user and then this traffic will be permitted to is forwarded to umbrella. We do create umbrella policies. In this case, Cisco umbrella policies are created and then enforced. So from umbrella dashboard, we go to policies, management and firewall policy. From this page, customers can create policies and that will be applied to umbrella cloud firewall. So since it's API, wherever you try to see API, application programmability interface. So using this API, any end device can push its configuration and it will be enforced to the devices. So initially, WAN edges will take the configuration only from vManage. When this is integrated, this is Cisco's design. When this is integrated, Umbrella can create its own policies and Umbrella created policies can be installed or it can be enforced to WAN edges. So WAN edges can take configuration from vManage through its netconfig API or it can take the configuration from Umbrella itself. For this testing, umbrella creates the policies and they will be enforced to the WAN edges. So we go back to umbrella. For testing, for the end user testing, this is the end user testing computer. We try to connect port 444. Test port is using a command and then Facebook, which is accessing, and then IP check, it is happening. Umbrella test. It is not happening, or maybe you can reload this page once. Oops. Okay, so now we will minimize this testing machine. So overview, deployment, and now I go with policies. So network management, DNS policies, firewall policies, and then web policies. This is like DNS communication, DNS scripts, firewall policies, and then web policies.
So web policy is nothing but the URL filtering kind of thing, or how it is?
Exactly. Now, sort of Cisco is maintaining. Suppose there are two. Cisco can manage this umbrella. When Cisco manages umbrella, they will create a policy like what DNS related security functions and then URL related functions and then firewall policies. Based on that, end devices will forward the traffic. Or if umbrella is dedicated to a customer, so as a customer, we define our own policies. So we can create policy, what traffic to be permitted, and then what traffic not to be permitted. So in this example, what Cisco has done, this Cisco umbrella given to customer itself as a customer perspective. Cisco umbrella owned by customer. So customer configures and then customer deploys its own configuration regarding security policies. Okay, so under policies, management firewall policies. So we can create policies that will be applied by the umbrella cloud firewall. So we will add and we will create a rule name and we will block port 444. Go to here under the firewall policy. Default route. The firewall policy management. We add a new policy. This is rule rule 1 port 444, and then associated configuration protocol. There are so many options. We will look for the port block. Then that it nothing but like normal access list only. Okay, so priority order description. Destination maybe. Rule name port block 444. And then rule criteria, destination port, specify the port numbers. So destination ports, we specify the port 44. And then rule schedule. This is like from where it's like immediate. And it doesn't expire. So it is already selected. So we enable and this port block will not be expired. And then rule action. We will block the traffic and we will enable the logging enabled, and we save these policies. We just block the traffic, we enable logging, firewall rule is enabled, and then policy. So we do have rule number 1, port number 444. Rule is enabled, and this is to block from any protocol or maybe from TCP or UDP, any source to destination, any IP, one port based for port number, and hit count is 0, and no more other informations. Like rule 1 is active, and we do have a default route. Policies, default web policy, like policies management, web policies, default web page, and the default page they wanted to create it. Management, web policies. So policies, default web policy, we will enable it. So default web policy. we go with application settings and enable edit. Under default settings, I will this is a default web page. We do see options like content settings and then applications. Lot of options available: HTTPS inspection, file type control, file analysis. Just went till this applications. This is by default enabled under the application settings. We add a new application. Choose Facebook. Choose Facebook. So this content will be blocked. This is like URL filtering. So Facebook is now blocked. So what happens here under the firewall policy, we blocked port number 444, and under web policy, we blocked the Facebook. That's what the is about to tell.
It's 444 or 443?
No, in this lab exercise, they created 444. Normally, it
Oh,
goes through 443, but
yeah.
this application server, they run with 444. So one port number for TCP port number 444, they blocked it.
Okay.
Okay, so in umbrella, DNS policy, firewall policy, web policy. This is URL filtering, and this is access control list, and these are DNS configurations like DNS IPS. You can say it as. So we enable one policy under firewall, one policy under web. Under HTTPS inspection, click enable and then edit. So HTTPS also will be enabled and inspected. So HTTPS inspection, because this option they wanted to say enable or disable. Now this is enabled. Now you can see. So Facebook, I permitted it here. So even now you can see a message under application settings. So Facebook will be blocked. And on the HTTPS inspection, it is here. And HTTPS inspection. Yeah, it's enabled by default. And yeah, I think we don't have to do anything here. It's already, this is the option to enable it or disable. If this is disabled, then we can enable it, but it's already enabled. So here it shows HTTPS inspection enabled. And we set written, and then we need to go back to the user, protected user experience. Now from this user's machine, we try to access this port. It should not work, and then Facebook should not work. We save this configuration. Okay, so now this is saved. Now I go back to this student machine and port number 444 test. So the browser will open umbrella test. Close this. Open the Firefox again. Umbrella test. Not opening, and let me check. It's opening Facebook. This page will fail and load.
And Cisco is doing advertisement for Facebook. Free advertisement for them.
Yeah, so we just say rule, and there is no hit over here. So rule number 1, and any IPs. No hits as of now. Then we go back to vman. All the devices are connected. I will go to devices. This is the one which we need to test it. Running configuration. SIG is enabled. Keys, VPN, SIG enabled. Another is created. The unnumbered. The policies are not yet pushed here. That is when we are trying to devices online pre-checks. Then templates. Branch type 2, 22 feature template. It is fine. I'm sending the configuration. The testing is failed. Go back to this network tunnels. On the VMAN, umbrella tunnels are fine. When we go back to the policy, firewall policies. Okay, it's when normally this is sometimes browser capability. When this is available with the local caches, from the local cache, it will try to load the content. Because there is no heat I could see. I'll try to clear the caches and we'll try.
Settings.
I'll use a different browser. We cannot display hits. There is no hits over here. So let me test the policy. These are permitted and any protocol. Okay, this is through TCP. Source tunnel is any. Source IP any, and source port number is any. Destination IP, destination port is this. Okay. I think time only. Start time is 7:45, and here this is 3:02. I think time I try to modify. So now I try to send a hit. Let's see. Dot facebook.com. No, it's not blocking it. Okay, I think try one more time. We can find it because we did all the steps. So this is the step in process. Enable it.
You can't tell me that the expire. Can just we can't set the expiry date there. I mean, I put only the start time. So
No, it's reset more time, so I think it's permanent. I could select it.
there only it's edit.
So source protocol, I mean protocol TCP, and source is any, destination is any IP, and port number is 444. And we said it's UTP, I mean UTC 3 AM.
There is no option to see any logging over there. I mean,
No, if there is a hit, it will show because the PC is not sending the traffic.
okay.
Okay, so expiry date, if it doesn't expire, if you say it doesn't expire, means like it is permanent entry. If you unselect it, then the expiry date will come.
Okay, okay.
Maybe January 28, I try to keep it AM before time I try to make it, and then save this configuration. This is updated, and I go back to question. Try to open the port, the specific port number. Port 44 test. It should access this. They mean to say the experience. So we Firefox, and we open the umbrella test and ensure that client is using umbrella. Now the client is not using the umbrella. That's what, it's not using umbrella. If it shows as using umbrella, then all the traffic will get redirected through umbrella itself.
So, Parthiban, in general, when we do troubleshooting, we log into firewall and see whether hits are coming or not, which hop it is hitting. That kind of test can we do here?
You can do it. Now this is implemented at the branches, right? So in the branch routers, we can test it. So we can go to vmanage, and if the policy is enforced, okay, so now we are at vmanage. If the policy is enforced, we go back to the device under the network and branch 2vh1. Now in this place, like firewall or on the security, so now we can find firewall policies and URL filtering. This place we are supposed to receive the policies. If this is fine, and everything will be accessible, then what page it is blocking, and then what hits, from where the hits coming, and even in the firewall policies we can validate it. So now the policies are not pushed here. That's what is not happening here. to redo that. Then only we will be able to say this. But maybe if you get time, you can practice it. That's what even I can suggest, because still tunnel it is fine. So the tunnels are created. So only creating policies, or else we will have to create the policy once again. Go to policies, management, firewall policies. We will have a new rule port and destination port specified.
Do we have the umbrella labs? What we are doing now? So it's part of our normal lab guide.
No, this is available in your D cloud. So anytime you can reserve one lab and you can practice it.
Okay.
Okay. So next option is connecting the SD-WAN fabric with cloud-based networks. Up to this, we talked about fabric components and its internal communication. For the internal communication or with internet communication, enabling them securities. Okay, so whatever it may be, the default behavior or default security functions we wanted to enable, we can enable them. And these configurations about the security policy will be enforced to the end of devices. So now, fabric communication between the branch and the data center or branches, or branch devices security. Wherever the devices security to be enabled, we can create the policy only to those devices via template. We can send them policies. So remember, template is an important feature which is available in the SD-WAN device configuration. So devices, for example, system configuration. So each device, what system IP, host name, VBON, organization name, site. So this information, and VPN 0, VPN 512, service VPN associated routing protocol configuration. Then we try to configure additional configurations like policies. So any policies to be enforced or any security features to be enabled on the devices. So even security configuration, policy configurations will be updated through template to the end devices. So one template will carry the device specific configuration and device security policies and device control and data plane policies. So we have this template based logic so that we will enforce the policies towards to these boxes. Then on top of that, when the devices are with the configurations, okay, now we can connect them with fabric internal MPLS transport connection or internet transport connection, and they do talk with direct communication part with security or without security. We can streamline it. Now, once the standard designs, standard network configurations are implemented, whatever the things we have discussed, physical data center present in present for one organization, physical branches are available. So source and destination is reachable inside the traffic of the fabric communication path. But the new trends, the current technologies are moving like applications. The organizations are not going to host their destination applications on the data center. Instead, they are going to host their applications on the cloud. So they go with cloud, maybe with the public cloud or private cloud infrastructure. They host all of their internal applications. If this is the case, they have two options. An organization can purchase software as a service application. Maybe only the destination servers and destination server applications are available. And in case of infrastructure as a service, where we will reserve a cloud-based data center, a virtual network, a virtual VLAN or virtual subnet boundary, we do get it from the service provider. We maintain our own router, we maintain our own routing boundary with routing protocol. Behind that, we do have our application servers, and applications are hosted on top of that. So when a customer network is moving towards to the cloud, a customer can install their applications on the cloud applications directly through SaaS, or customer can own and can manage their infrastructure as a service data center on the cloud-based infrastructure as a service data center, the applications and then the servers might be running. So we have to have the reachability towards to these applications from the WAN fabric. So across any branch or across location, if a user wants to communicate with cloud-based application for an organization, or if they want to talk to a cloud-based application behind the cloud-based data center. So how SD-WAN fabric is going to differentiate? This is the traffic supposed to go to cloud-based applications on the public network or cloud-based applications on the IaaS-based network. So cloud-based recognition or cloud application-based recognition could be and supported or enhanced feature available on the WAN edges. So obviously the basic idea over here, whenever we are introducing WAN edges, when the traffic is given from the end users, now this WAN edge will classify them. This traffic has to go from this WAN edge into the fabric towards to the data center. For example, physical data center and then regional data center and cloud-based application on the public net. So these ISPs, they have these WAN edges will have ISPs connection, and ISPs are connected across the WAN fabric, and even these devices are connected with the ISP backbone and then ISP network. Now these ISPs, some of the ISPs will have only the dedicated path and then dedicated communication like MPLS, and even they might have the connection to this public network. And some of the ISPs, they can have direct communication path to the internet or to the cloud-based applications. So in this picture, we do take ISP1 has connection to the public network. Through the public network, cloud applications are accessible. ISP2 cloud applications are accessible, and MPLS2 connected to data center as well as MPLS providers having the reachability to cloud applications. So now this WAN edge receives the traffic and classifies the traffic source will be this, destination is this. The traffic will be going inside the VPN tunnel. So any IPsec VPN tunnel is built, the data from branch to data center will be communicated. Similarly, any traffic to go from here into public network, then it goes to ISP1, and through ISP1 through local internet, it reaches to local internet boundary, or it can go to the cloud application. So now this WAN edges will classify the traffic based on the classification, and based on our cloud traffic handling mechanism, it forwards the traffic to internet. Whether this internet is directly going to the public network, or this is going to have any breakout connections, or this is going to have any data center or regional breakout connections via a gateway devices. So the first option, what we can try to analyze it here is SD-WAN fabric can be connected with cloud-based network. When they are connected with the cloud-based network, WAN edges will classify the traffic based on cloud application or based on the application, and depends on the shortest path available through the direct internet circuit or through direct cloud circuit, the traffic will be forwarded to the destinations. So any traffic from source to destination depends on the destination. WAN edges will go for the dynamic intelligence selection of the path selection and forwards the traffic to outside network. So this
So
cloud up, yeah,
the
yeah, go ahead.
dynamic, the dynamic best path selection based on that BFD.
No, in this case, BFT won't come in picture because BFT runs inside the VPN tunnel, right?
Yeah.
We have VH1 and then VH2. When we form the VPN tunnel through internet 1, inside the VPN tunnel, we do have BFT, and second VPN tunnel, BFT, then third VPN tunnel, then BFT. So BFT will tell tunnel 1, tunnel 2, tunnel 3, then quality of each tunnel. Based on that, we will decide the best path. Now,
Okay.
if there is a traffic coming from private network from this local boundary, and it's supposed to go to the office applications. Now this is available on the typical internet or typical public network. Now what happened? This is connected with internet, and then this is connected with internet. There are two circuits available to talk to internet. Now when there is a traffic, okay, when there is a traffic towards to Office 365 or Google, This router knows ISP1, ISP2. It cannot run a VPN tunnel, isn't it? So it cannot take BFT session and then it cannot take BFT session. This
Okay.
VNet will initialize a tunnel, I mean BFT, but who is going to be the responder? So nobody in the public network will respond to it. So cloud-based application, dynamic path selection is not based on the BFT, and this is going to make use of the public traffic itself. So no BFT will be used. DNS probing and then HTTP or HTTPS probing will be taken care by the WAN edges. So WAN
So
edges,
if
yeah.
if no BVFD, so if I have ISP 1, 2, 3 like that, which path it will get selected? So it will send the DNS probes like I mean from all the paths, so whichever responds quickly, so it will take that path, or is there any other mechanism to
No,
finalize the?
no, exactly the same. Okay, so if internet path number one, internet path number two, internet path number three, there are three internet paths on the WAN edge. If a user is trying to request www.google.com, now WAN edge will in DNS query. It understands it's supposed to go to google.com. Now three DNS queries are locally generated. WAN edge router will generate the DNS query and sends to ISP1 DNS server, sends to ISP2 DNS server, and ISP3 DNS server. So three DNS query will be sent and will wait for the response. So which DNS server's response latency is less, this is preferred. Along with second option, WAN edge router will send an HTTP request itself. If you are asking for an web page, WAN edge will send HTTP request through internet path 1, internet path 2, and then internet path 3. Then what is the response for HTTP? So DNS response latency, HTTP HTTPS response latency, both are compared and then both are validated by WAN edge. Then WAN edge will decide ISP2 DNS response and HTTP response is the fastest one. So that will be the best path towards to Google application. It decides it.
Fine, fine. So there is nothing, no specific any protocols, or there is no algorithm to run except the DNS and HTTP requests and response.
Exactly. So this is the only one, this is the only one concept plays in the cloud-based application or internet-based application reachabilities. We place Vantage. Vantage is taking the traffic from the LAN, and Vantage should classify whether the traffic has to go to the data center or the traffic has to go to internet public or to the public application. When it is classified, it's supposed to go to public application. Now WAN should know how many internet connections are available. Out of internet connection, which internet connection is the best for performing internet connection. Just to validate, then the user has requested for Google, or user is requested for Office 365, Dropbox, Salesforce, whatever it may be. Then internet connection one DNS query, internet connection to one DNS query, and then a response, HTTP query, HTTP response, then decides, okay, out of two links or out of three internet links, this is the link giving good DNS response and then HTTP response. Then feature connections or subsequent connections will be forwarded into the best selected path itself. This is how it does it. Other than that, no tunnel establishment towards the cloud SaaS based application, and then no BFTs or no encrypted communication with it. So no encrypted communication, because if Vantage encrypts and on the public internet cloud, some device should decrypt it. So nobody is ready to decrypt it. So we don't enable encryption and then decryption towards the cloud applications for SaaS.
Okay. So what if I have put all my secure infrastructure in the regional data center, like I have put all, proxies, IPS, WAN accelerators, or all AMP. So everything I have put on my regional data center. So since the Dropbox, Office 365, Google are plainly accessible through the public internet, but there are chances of security compromises. So I would like to have my traffic, whichever is initiated, I mean the destination is on internet. Then I just wanted to get this to pass through the regional data center, gets scanned, secured, everything. Then it has to go to Office 365. So that
Yeah,
is also doable, right?
we can do that. Okay, so now whenever we are trying to configure the cloud access or for the internet access, basically under the cloud configuration, we will have to tell these cloud applications are directly accessible, direct internet access, or they are accessible through regional breakout or the data center backhaul. Basically, these two things will involve the same logic. So whether it is direct internet access or through any regional breakouts. Even both the combination also we can do that. Suppose if there is a situation ISP1 is connected here and then ISP2 is connected with the internet and then data center is also connected with the internet and everybody connected with the public network. So now what happened? Option number one, when the traffic comes, this will classify. It's supposed to go to internet. If I define ISP1 on vantage number one, it's a DIA, direct internet access circuit. If I configure this is a direct internet circuit, and if I configure this is direct internet circuit, now what happened? Between these two direct internet circuits, the traffic will be forwarded. So it sends, okay, there are two links. One link will be here, direct link, then cloud traffic will go to the destination. Then second option, I don't want to do this. Now I want to send it them through the gateway itself. Now when I'm configuring the cloud-based application reachability, in the cloud-based applications, we will tell, so this is the regional data center. This device is configured as the gateway, cloud gateway device. So we can configure that as a gateway. So now in this one, in the cloud access configuration, any traffic to go to this destination application, and this is supposed to be forwarded to the tunnel pointing to this default gateway. So now it receives Office 365 traffic. Though these devices are available with direct internet connection, this is encrypted and then encapsulated. This encrypted traffic will be given to the destination of this Vantage device. After the de-encapsulation and then decryption, this device will select. This traffic will be going to the destination internet connections or destination internet applications. So this is also you can configure it. This is configured as cloud connections or cloud access configuration via gateway. So these two options we can do it whenever we are initializing cloud-based application reachability for SaaS, which what we are talking about is SaaS-based application. The SaaS application reachability can be configured using direct internet access method or can be configured via the backhaul through the gateway configuration. Even some users bit smart and or if there is a situation that I want to have one connection through local service provider and then one connection through gateway. So now this connection goes to this public network. ISP2 is connected to this gateway. So this Vantage will have the internet traffic. Then it reaches, when it reaches the Vantages, it says this is going to go to destination cloud application. Now, one path is directly connected with internet and one path it is going to go through the gateway. So encryption and then decryption. After that, this will go to internet. Even this combination also we can do that. So only internet, direct internet access or only gateway, through gateway all traffic to go to the public network or mix of these two combination. So one link with direct internet access and then one link with gateway. Even this combination also we can do that. So these options are doable and it can be enabled on your SD-WAN fabric.
Okay. So normally in SD-WAN fabric, so we would be having MPLS or internet or 4G, whatever the number of transport mechanisms we have. So it's like in current technology, normally if you see, we have dual links to the service providers. I mean, from the customer edge C routers. So normally when the traffic will be going on one link, which acts as a primary and secondary will be idle, only the primary fails and it fails to secondary, and then secondary will take over, the traffic passes through secondary till the primary comes back, right? So
Right.
here in the SD-WAN by default, it's like active active or it's like active passive.
So it is active only. So any link which comes with better performance, then traffic will be handled. Suppose sometimes like for the first time, the Vantage is receiving the traffic to internet and it chooses direct internet circuit. Now, when the direct internet circuit is choked, then it will change the traffic to go through the gateway itself. Then gateway's performance is better, then traffic will go through gateway itself. So anytime for the given period of time, best performing circuit will be forwarded with the internet or this cloud kind of application based traffic.
Okay. Now, what I meant is like, see, I have two circuits, MPLS as well as internet. So on both the links, the traffic will be simultaneously flowing, is what I'm asking. Like no active primary concept, something like that.
No, 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 no. Okay, you mean to say load balancing, right? So 50% of the traffic through MPLS and then 50% of the traffic to internet.
See, like that way, or if not, I'll just see that. See, I have MPLS link wherein I use that particular MPLS only for critical applications, like a payroll or any critical applications, critical traffic, like a business class kind of traffic. I use it for MPLS. Okay, and other than that, for all other things, I use internet for any internet-based destination or non-commercial. I mean, commercial traffics, all those things. I use internet as a service. So I want business class traffic to be passed on MPLS. Whenever the end users generate that specific destination, which has to pass through MPLS, which should be active all the time, and simultaneously, end user may generate the internet traffic also, like he may use a access Google and other stuff, or some customer servers which is reachable through internet also. So both end user would be generating the traffic for both MPLS and both the destinations. Like so few flows will be for MPLS and few flows will be for internet. So it means that the traffic would be coming for MPLS links as well as traffic is coming to internet also. So both the links will be working active at that point of time, right? Or how it is? By design, I'm asking, by default.
By default, it will be, but we don't have any control. Suppose you are sending business applications or business critical application, MPLS may be the best part. So when more application traffic is going with MPLS, let's say business class applications are choking the bandwidth. Now, then Vantage will choose, okay, internet link to transfer the business application traffic.
Mm.
Okay, and vice versa. So internet traffic can go through MPLS. If MPLS link is choked, go through internet also. So we don't have any control whether it is MPLS or internet destined traffic. For that current situation, what traffic is selected for what physical interface or for what tunnel, then traffic will be switched over, because dynamic path selection is always based on the best performing path, irrespective of whatever it may be the data to the destinations. But we wanted to have a strict control. My business critical application has to go through MPLS, and then normal traffic has to go through internet. Then by creating the policies, so by creating the application aware routing policies, we can achieve this.
Okay. See, generally, as of now, the networks aware is like we have the primary, secondary concepts, and always the traffic goes on primary and secondary will be idle only. So always traffic goes on primary. So even if I have 1 gig link on primary and 1 gig link on secondary, which I would be, because of redundancy purpose, I may take 1 gig link from Bharti and 1 gig link from Tata and configured Bharti as primary, and 1 gig link, all my entire campus traffic is flowing through Bharti, and 1 gig link of Tata would be idle, and I'm not, and I'm paying for the bandwidth for them, right? So only Tata link will comes to picture when Bharti goes down. So the reason being why they put active passive is that if both the links are active, so the real-time traffic, there are chances if any link breakage or if any interface goes down, that traffic will get dropped. So that's why they generally uh, configure it as active passive. Only when active fails, so passive will become active. So that's the concept. So here,
but
if yeah.
but here this is not the case, because just to overcome that problem only, the solution itself they designed. So though we have secondary link with enough bandwidth, until or unless primary link goes down, we don't use it, but we are paying for it. So now in this situation, what happened? You maintain both the links. If any situation, if primary link is overloaded, if this is choked, when bandwidth is not available, or compare with primary, secondary bandwidth becomes very good and performance is very good, then Van Edges will automatically choose the traffic to go through secondary as well. So These routers will forward the traffic on both the links. We don't have to waste any of the link, but we need to have a control of it. So what traffic goes over internet, what traffic goes over MPLS. If you don't have the control, any traffic can go through any path, because the nature of the design is to make use of the both the links. But which link is utilized by which traffic, we don't have a control. So just to have a complete control, we create policies, application aware routing policies. We design this is Office 365 and this is Office Microsoft application and then Google application. They are available in the internet. Then we choose this traffic should go through internet path. Then private subnet or private IP addresses, the internal server data center. Then we can choose them to run through MPLS. We can do like that also. Or even MPLS has an internet connection to this application. So Office 365 is a business application. So it can go through MPLS. Like normal browsing, normal downloading, they can go through internet. So by defining this, we can control it.
No, for the policy set, we have defined, right, which for example, Office 365 traffic has to be go via internet like that. We have to set a policy, or the system will automatically choose.
No, system will not choose policy. We have to create the policy and we have to apply the policy to all managers. Okay, because it's a router, it's a managed router, and when the traffic comes, okay, router cannot understand it's a business application or business critical application or a normal traffic or a vulnerable traffic. Router has no intelligence of it. So we are introducing first the intelligence as like you just classify this is the Office 365, this is Facebook, and this is Google, and this is ICMP, this is like vulnerable traffic. So we are putting some intelligence for the router to make use of the intelligence. When router classifies, then router can tell, okay, so you take this application traffic to MPLS, you take this application go through internet, this supposed to go through in 4G. Like we are making our manual decision, manual configuration with the help of policy. Based on the policy, router will balance the situation. So policies are very much important.
How we set the policies, because based on category wise we have to select the policy.
That's what we are creating applications, right? Application list. While we are creating the control,
A lot of URLs available in the internet. How do we know which category this URLs are come?
No,
How do
this
we
is
set the policy?
yeah, these all are already categorized by viptela. So viptela has categorized. You try to go with Google. If you select a Google application, inside Google application like Google Drive or Google Maps or Google Excel, so whatever the Google specified URLs are available, that will be available in that bundle itself. If you choose a Facebook, inside the Facebook, how many URLs, how many sublinks they have created, everything will be permitted. So 1400 plus standard application and its subcategories are categorized already inside the software itself. So we don't have to create each and every application and its specific subcategories.
Agree. It's based on URL or it's based on IP. Because if it is Office 365, it's hosted in the cloud. Maybe the IP will be vary, right? Because of it's not a static IP, it's a DHCP.
No. This is not based on IP address. It is based on name only. That is why we use application name and application list.
Okay.
Yeah.
The categories, all those things will be taken care by the proxies, web content filtering you have. And also in the vManage, you have, I mean, in Umbrella, you have seen a section called web policies. Normally, if you want to know which site comes under which one, if you just go to Blue Coat, if you just put that site, it will show you it falls under what category.
So those things are already categorized here also. That's what I mean to say it here. Now, if I go back to, let's say, policies.
Yeah.
So remember, I just create a policy. So here we do say an application list. The moment we choose Google Apps, okay, and inside that we can find all the information. So Google Apps will have a subcategory of Android updates, Blogger, Gmail chat, Gmail Drive, and then mobile services, and docs, downloads, Google Play Plus, safe browsing, Gtalk. Okay, all Google specific logics will come in here. Microsoft. So in Microsoft, link, Skype.
Even we can modify and add also, right? In case if something is new, you can modify and add also, correct?
Yes, you can do that. So new applications in that. So almost like all the applications you can find it. So here box and Disney, Facebook, GMT, Google Photos, Hypertext. And I think as I told you, like around 1400 plus categories are already predetermined. So we can choose whatever we wanted to place it. And we can search it by typing it here. Let's say Facebook. This FB application list. While we are adding inside that, I think Facebook is only the only URL permitted in this one. And Office 365. So you can whatever it may be, the options are available and then predetermined. We can do even further customization we wanted to do. We can enable that also. So this is like predetermined. Based on that, we can create our policies, and we can add them here. So Office 360. One application is here. Will be available. If no subcategory, like only this specific URL to be permitted, it permits it. You can choose its only application or application family. Yeah, like this. So multiple applications in this place. So this application, and then once we are creating various applications, then under the control policies, under the traffic policies. So obviously they won't play anything on the control policy. You go to the traffic policy, and inside that you can see application aware routing. In application aware routing, along with SLA also you want to determine, you can determine. If not, you can ignore the SLA compliances. Directly you tell that this application is supposed to go with MPLS, and then this application has to go with internet. Basically, you can determine it. We can create various applications in the application list, and these applications are going to be permitted through what destination, what particular places, or what specific link we can categorize under the application routing policies.
Yeah, Parthiban. Yeah, clear. Guys, any questions? Murugan, Venkat,
No,
Vishal?
No, Navin.
Okay.
Okay. So
I have one question for you.
yes, sure.
No, not for Parthiban. I have one question for Naveen. Okay.
Tell me, Murugan.
See, for example, the KP account, we have requested to add W3 inside the applications. Okay. So AT&T has added, but most of the times it is not working. If you ask to AT&T, they said the applications are hosted in the cloud. That is why the changing the IP address, it is not accessing now. So if they allowed based on the host name or based on the URLs, it will access any time, right? If the IP also change it, correct?
Yeah, so where it hosted, so what need to be allowed? So if you are hosted in a third-party data centers like Akamai and somewhere else, so that the IP for the respective servers will get changing. It would be changing on a round robin, okay, basis. Akamai having almost 3,700 plus edge servers across the world. So from which location where you will pick it the server and you will get it, we don't know. And if we specifically put one IP and allow that it's what it is, if the IP gets changed for next 24 hours, it will not work.
Yeah, I agree. But see, why you are putting in the IP based solution? You can put it the host based.
Now we don't we have put on a category domain based only in the proxy what we are using blue coat.
Now, in the same scenario here also, if you put it on a category based, here they won't put it on IP based, right? They put it on
We are not putting any IP basis. See, they do not mix up with IBM things. IBM has a lot of standards and things. Okay, for
options available. Why AT&T is denying to put it? My question. That's it.
No. See, W3 is not a commercial traffic or anything on internet. The W3 is IBM owned. So to access from commercial things to access the IBM Blue Enterprise things, so there are certain security restrictions and a lot of things is there, Murugan. So I can just explain that offline, okay?
Okay, fine. Oh, sorry, Parthiv.
It's okay. It's okay.
Okay.
Yeah, anything and everything is possible technically. But the compliance portion, security portion, which comes,
Yeah, that
which
answer
fills
only I
the gap.
needed.
Yeah,
Everything is possible. I agree. That answer I
yeah,
expected from you. Okay, thank you.
yeah.
Yes.
Yeah, Parthipan, please go ahead. Sorry.
Oh, it's okay. It's okay. All right. So we do have cloud on RAM for SaaS and cloud on RAM for IaaS. So first we talk about IaaS, SaaS, then we'll go to IaaS. So in case of SaaS, as I told you, like direct internet access is the first option. So whenever we try to see the direct internet access, so ISP1 has a connection to application and ISP2 has a connection to the application. They do have a direct internet access. So whenever the traffic comes into the WAN edges, so they see ISP1 link 1 is preferred and then ISP2 link is preferred. Now, between these two link, and we will mention like which path is the best performing path. Automatically, they will be selected. So now what we try to do for this cloud on RAM for SaaS configuration, we will tell that so applications, we need to create the applications. So in this case, applications will be classified. For example, this is Office 365 or whatever it may be. So now we will classify the traffic. When this is classified, for this cloud on RAM SaaS communication for Office 365, I will map, okay, connection one, direct internet connection. For example, connection number 1 and connection number 1, 2. So I will, sorry. So I type it here. So application as Office 365, and there is an Office 365 application comes in. This router will classify, and this router needs additional configuration. So under the cloud on RAM for SaaS, our configuration should tell that ISP1 is the first direct internet connection, okay, direct internet access connection number 1, and then direct internet access connection number 2, ISP2. That means two physical interfaces we will have to map it on this WAN edge, port number 1 and then port number 2. Okay, even if routers are changing, so routers are different devices, a common policy to be enforced to many devices. If this is the case, what we can do, we can choose the color also. Whatever it may be, the interface specific local TLOC parameters like a system IP address, TLOC color, and then TLOC encapsulation. So this color also we can choose it. So Office application 365, and then this, when this is selected, it can be sent to cloud. When this is going to cloud, it can choose, for example, gold ISP color 1 path and then silver ISP color 2 path. Now when these two configurations are mapped, then WAN edges will do that. Okay, traffic comes Office 365 gold and then silver map, okay, through gold link and then silver link, send the DNS query, wait for the response. Silver link, send the DNS query, wait for the response. Then both the links HTTP request and then HTTP response. Then router will decide, okay, gold circuit is best performing. Then this Office 365 will go into ISP1, that is gold circuit interfaces. So direct internet access is a configuration. Basically, even while we are enabling cloud on RAM, we will tell that for this WAN edges, this internet traffic or application traffic towards to the cloud has to go through direct internet access method or direct internet access and with a default gateway option. And in this case, one configuration will be direct internet access, then second configuration will be gateway. We do define that. So direct internet access detects application performance through one or more direct internet circuit. Is nothing but sending DNS query and waiting for DNS response, HTTP or HTTPS request, and then wait for receive the HTTP responses. Based on that, the internet links and associated performance is measured. So vEdge router choose best performing path per application per VPN. So every application, then path selection will take it place. Even if you don't want to give application specific, complete VPN also, we can map it. VPN 2, it's for internet users or it for guest users or whatever may be the purpose. And any traffic comes into VPN 1, VPN 2, VPN 3. So completely this will be taken to like cloud and RAM for SaaS configuration with the direct internet access. So classification can be based on application or it could be classified based on VPN. Automatic failover in case of performance degradation. That's a default behavior, dynamic path selection. Even in the VPN tunnel using BFT, dynamic VPN tunnel path selection takes place. And when we have direct internet access configuration, any internet circuit which is giving the better performance or better response for DNS and then HTTP will be automatically selected. In case of one link failure, through other available link, the data transmission will take it place. And this is fully automated. So we do configure cloud on RAM for SaaS direct internet access configuration at vmanage, and vmanage can push the configuration to the specific site. It can go to site number 1 WAN edges, site number 2 WAN edges, site number 3 WAN edges. So we can push them into the respective sites. Okay. Whenever we do the configuration, in the first step, we do create the application list, what applications we are going to classify. And then second option, this is going to be with direct internet access or DIA and the gateway. Then if they are trying to talk with direct application and then configuration, and they are enforced to what site. So what site and then what site IDs or what site informations will be collected with these details. So site ID and then site related. So if you talk about like site 10, site 20, site 30, site 40, so under what site, what WAN edges are going to be enabled for this cloud on RAM SaaS with the direct internet access. So these three steps of configuration we normally enable it. Okay, so the first option is direct internet access. Now, when we talk about the second option is direct internet access and also with the gateways. You look at the scenario. First connection from the WAN edge to the application goes to local internet service provider. From there, it reaches to the destination application. Second connection goes to MPLS. Through MPLS, it connects to the data center. Think that this MPLS has no reachability to the public network. Through regional data center, using its local internet circuit, this is connected to the destination applications. So there are two options. Now, same logic, when the application traffic comes, it classifies what kind of application is this, and a DNS query will be sent over here. So DNS request will be sent over the first physical port, to the public network, and DNS query will be sent over the fabric encryption, and then de-encryption will take it place. And after the de-encryption, de-encapsulation, DNS query will go to this local DNS server. Then HTTP request through the local circuit, and then HTTP request through the gateway device into these applications. Now, based on the DNS response over this and the DNS response from this circuit, are based on the HTTP response from this both the circuit. So by validating both the circuits DNS and then HTTP responses, this vEdge will choose for this scenario. This is the best performing path to reach into application. So all the application coming from here, they will be taken into the gateway path and then they will be connected to the destination application. Or if this is overchoked, all the traffic will receive, they will take to the local network. Through local network, they will be given into the destination applications. So detect application performance through direct internet access. Okay, accesses multiple paths also you can do, and also you can give it gateways. Even multiple gateways also you can do. There are two gateway paths and then two internet paths, like 4 circuits total to talk to the cloud. Not a problem. One DNS query will be sent over 4 physical paths. I mean 4 destinations, and then through 4 physical paths, it will just calculates the best path, and the best path will be transmitted with this cloud application based traffic. And the customer or service provider owned and operated, security, performance, and then reliability. So VH router choose best performing path per application or per VPN. So we can tell application 1 direct internet access and then gateway, application 2 direct internet access and then the gateway, or complete VPN traffic can take with one direct internet traffic as well as the gateway internet traffic. If there is a situation for a company, they have a branch to internet traffic. In this case, like branch loses the local internet circuit. Now all branch to the public network or internet traffic will be taken to the data center. Through data center, they can be redirected. Or if data center path is taking production traffic, then we can create a regional hub or regional breakout, maybe one a new location and then new WAN edge router which has the internet connection. In this case, all internet connections will be redirected to regional hub based or data center devices, and from there they will connect to the destination cloud applications. So it typically depends on the design. So more applications or more data center devices or private data center resources are available here, and this regional data center is meant only for the internet connections. If this is a case, obviously like the devices will receive the traffic, and receive the traffic will be sent through the local provider network to applications, or it could be sent through the gateway. Through gateway they will be connected to the destination applications. Okay, so this is the option number 2. There are two options we can enable as part of the SaaS configuration. So one traffic to be here, and then second option, and then second applications to be through the gateway devices. Okay, any questions?
No, Parthiban. Good.
No, from my side. Thank you.
So yeah, we can compare it like how things are happening. So dual internet access service providers. So here internet and then 4G, though they say the picture over here, but actually the physical representation will be this device will send the traffic to internet, and it sends the traffic to 4G. From 4G it goes to here, and from here it goes to ISP. From here it is reaching to destination applications. Or one side this is connected to MPLS, and second it is connected to the ISP1. So now path number 1 and then path number 2. So through path number 1 tunnel, the transmission take place, or through the ISP, direct ISP, it can talk to the internet. So dual internet access, sorry, direct internet access and then gateway, or dual direct internet access ISPs. So how the
Hey,
best
Parthiban,
path?
what is the industry standard?
No, as per Cisco has not provided any industry standard. They are giving options only. Suppose if a customer's requirement is they do have multiple internet local exits, so no traffic towards to fabric should come through the tunnel. So what option they can enable it? And some customers want to make sure the internet traffic for the local. In case any branch local connection goes down, it can be connected through regional breakouts. Then third one will be compliance. No branches will have direct internet access. All the communications only through the gateway, that is through regional hub or regional breakout only. So depends on the situation. Customer can choose it. Suppose if you have local multiple internet, then you can configure SaaS configuration with direct internet access. So two internet access configurations. And option number 2, one direct internet access link and then one gateway link. Option number 3, one direct, one gateway link,
Yeah,
no more direct internet access configuration. Yeah.
got it.
certain scenarios we should not follow Cisco, we should follow our own. So Cisco understand that in this place, whatever the suggestion Cisco gives, nobody listen to it. So they are just coming up with various options.
It's completely depends upon like how we design, how many campuses, branch offices we have it. So whether what kind of traffic and throughput which is coming in, whether it's we go for internet only or we go for MPLS plus combination of internet or MPLS alone. So it's we can choose.
Yep. So cloud on ramp for a SaaS. Okay, so how the path selection comes in picture. So this is what I was trying to explain it here. So when the user is trying to send any request to go to the application, first step, VH DNS query for SaaS application. So if any request comes in, VHS will intercept. So DPI, so deep packet inspection is nothing but VHS can read layer 7 headers. So normally routers can read layer 3 headers, IP headers, using that source IP, destination IP. If L4 intelligence, if firewall intelligence are introduced, or layer 4 intelligence are introduced, they read the UDP TCP header, and top of that source port and destination port, they will they will use it for classification. If routers are introduced with layer 7 intelligence, then they will intercept DHCP frame. On the DHCP, it's a request or a response or offer and an acknowledgement, whatever may be the message type. In every message, it will read it, what content it is carrying. Similarly, for DNS query, what information, DNS response, what information, HTTP, what is the request, and then what is the response. Like each and every layer 7 payload will be intercepted and then will be inspected. So that DPI or NBOR, so network-based application recognition in Cisco C edges, and for viptela VHS, we do have DPI. So using DPI, these devices will intercept DNS query and it will read the DNS query payload. On the payload, they will understand what URL is accessed for these connections. Then by intercepting the DNS query, it can classifies this is going to go to Office or it is going to go to Google or Salesforce, whatever it may be. Then it will send the DNS probe for the local DNS server, then DNS probe for the second service provider, wait for the response, HTTP request, HTTP response. Based on that, this will decide the path. So VH DNS query for SaaS application, VH probes SaaS application, exact SaaS application. Then VH calculates best performing direct internet circuit based on the responses. Okay, the complete picture is here. So user performs the DNS query for the SaaS, and DNS query intercepted by DPI and forwarded to DIA DNS server user. Here, and then user SaaS application traffic is forwarded to the best performing path. So request forwarded via best performing circuit as always. Even through the gateway also, the same story will take place. When we have the gateway, so users traffic to go to the WAN edges. So WAN edges, okay, this is a second step. They will try to intercept the DNS query, and then they will send one copy to local DNS server and one copy through the VPN tunnel. It reaches the gateway router, and this gateway router will forward the DNS query to local DNS server, response from local DNS server, response from gateway's DNS server, then HTTP request, and then HTTP response. Based on these responses, then VANEDGE will calculate it. So VEdge calculates best performing circuit, and VEdge router compares path performance and then select best path. Then the same logics will be followed here in this place as well. So this is a option, you can see it under the SaaS based application. So it's very simple. We determine applications, or we determine the VPN, any traffic under this application or any traffic under this cloud, and we choose this is supposed to go to like a direct cloud circuit 1, 2, 3, or it's one traffic or some traffic through path number 1. and then some path number through the gateways. So again, this is an explicit configuration, a separated configuration with separated license. So as we discussed in the morning, so DNA essentials and then DNA advantage. When we go with DNA essentials license, it enables only the security features for the fabric. But while we are going for DNA advantage, it enables the security features along with cloud-based reachability. So cloud application and cloud application reachability. So obviously, vManage should be updated with DNA advantage license. Then only we can be able to enable this cloud on ramp for SaaS and cloud on ramp for IaaS. So cloud ramp for IaaS is quite simple because we are going to have a cloud-based data center. On the cloud-based data center, we will install a virtual router, a vEdge cloud router. Virtual machine-based routers or virtual machine-based vEdges will be deployed on the cloud data center. When this is like a virtual router or virtual vEdge cloud or virtual machine-based WAN edges. Now what happened? These WAN edges, they will talk with vManage, they will talk with vBond and DTLS, they will talk with vManage, they will form the control plane net config session, they will talk with vSmart OMP control plane session, and through OMP they will reach the TLOC, they will form the VPN tunnel with each other through another WAN edges. That means it will be behaving the way like how branch routers or physical data center routers are connected. Similar way, even these cloud-based data center devices will behave it. In this case, creating policies, creating template, applying the security policies or applying the cloud specific profiles, everything will be determined similar to the local devices. So we don't have a separated logic or we don't have a separated concept for IaaS based devices because they are going to behave like how the physical and the branch data center or branch or data center manages behave into the network. So in this example, we do have SD-WAN with public cloud on the public cloud. So we do have Amazon Web Services, AWS. We create an VPC, and on Azure we create a VNet, and on the cloud-based data center we are going to own our vEdge. So AWS, in AWS you can deploy a vEdge cloud router. Even in Microsoft Azure we can deploy a vEdge cloud. So one virtual machine we can buy, and this virtual machine will be deployed as a vEdge cloud. So whenever this is deployed, and it is going to be a complete fabric device, enabling security, segmentation of configuring multiple VRF and configuring policies, the QoS, and reliability to cloud workloads. So end-to-end SD-WAN, normally we call with cloud on ramp for IaaS. So vEdge cloud routers are instantiated in every VPC or VNet, and end-to-end SD-WAN fabric between site and public cloud. So end-to-end SD-WAN fabric in the sense like these devices are going to form the VPN tunnel with, it's going to form the control plane tunnel with vManage and then vSmart and vEdge when with vBond, and then between them they will try to form the VPN tunnel with each other. So they are discovered inside the fabric. So obviously they will be forming the VPN tunnel with each other. So once they form the VPN tunnel, obviously inside the VPN tunnel, BFT will come in picture. So BFT tunnel measurement, every calculation will go for that. So like branches will have service VPN created. From here to the LAN side, we do run OSPF for local routing protocol to redistribute. Similarly, these WAN edges with vSmart, they will run with OMP, and behind from WAN edges to the VPC or to the VNet network, we can enable OSPF or BGP routing protocol, and then this associated redistribution we can enable it. So we can say like the LAN or subnet boundary created on the cloud-based data center or on the cloud-based infrastructure. So end-to-end SD-WAN fabric between sites and the public cloud. So that we can achieve whatever the fabric related concepts and then logic shortest path towards to the public cloud. Since like these WAN edges are part of the fabric, so all SD-WAN related logics and then concepts will be enforced to the devices. Configuring the template, configuring the policies, configuring the security policies, or making any like local configurations or any local monitoring we wanted to do. Everything could be possible through the vManage itself. So cloud on RAM for IaaS, which looks very similar to the local branch routers or the local data center devices. So again, this is available. These virtual machine based VHs are available on public cloud, AWS and the Microsoft Azure, and also could be presented through Cisco Cloud also. So Cisco Cloud, you can be able to instantiate this virtual machine. So gateway, VPC or VNet. So customer or service provider owned and operated. Security, performance, reliability. So VHU basically. Easy deployment model. So no change to the existing compute. And this can be fully automated from vManage. So since like these VHs are part of the fabric, and this device complete configurations will be possible through vManage itself. So this is like customer's choice whether they wanted to deploy only the servers on the cloud using SaaS. In this case, based on the DNS and then HTTP, path selection will complete so that configurations will go with direct internet access or with a cloud gateway configuration. Second option, the customer can completely create the data center on the cloud while they are creating the data center irrespective of application. All the network reachability will be provided through the gateway, that is virtual machine based router of the VH cloud or the virtual machine based to CCHs. And since these devices are going to participate in the fabric, complete fabric communication and segmentation, QoS, multipathing, everything we can be able to control it. And that is completely managed through vManage itself. So a quick configuration or how the scenarios are going to be for IaaS. So cloud on ramp for IaaS, gateway, it could be a VPC or a VNet. So in this picture, we do have virtual machine based routers. So VH router 1 and then VH router 2. From the cloud provider network, it's connected to two links. It's connected to internet and connected to MPLS. So as we are familiar, so two interfaces participating in VPN 0. So whenever we are initializing the router, it has got port number 1, port number 2. Port number 1 goes to internet. So TLOG for internet and then TLOG for MPLS using public IP addresses, they would be generated. And these TLOGs will be communicated to OMP, to vSmart through OMP, and then these informations will be communicated to other devices. So VH to vSmart, we run OMP, and this VHs to internal network. So it could be running with standard Ipsec tunnel, or it could be running with the BGP. So normally we run with the BGP. So on the VHs, we enable redistribution from BGP to OMP redistribution, and then vice versa. So internal subnets on the application servers will be redistributed to OMP, then OMP will redistribute to wherever the application VPNs or service VPNs are available for the network reachabilities. So cloud and ramp IaaS, the VANages are fully automated through vManage. Greatly simplifies brownfield integration, multipathing, security segmentation, and faster failover.
Okay. So what is the difference, Parthivan, between the IaaS and software as a service from the cloud perspective?
Okay, cloud perspective. Let's say if you say IaaS is nothing but we are operating a data center on the provider network. Let's say you have a data center, physical data center in Bangalore. Now, what happened for the Bangalore office? You have to have, let's say, server 1, server 2, physical servers available, and top of that, OS will be installed. Then, whatever the application, and for the network reachability, we need to provide Nexus-based networking or UCS-based networking or AC-based networking. That means that physical environment is managed and then maintained by the organization. So now when this organization data center is connected with the internet, we will take an internet connection, we will connect. So public network will come to these organizations access layer or aggregation layer or core layer, then they will talk to the server and then talk to the application, then resources will be taken. So similar design, similar logic, if this is provided by the provider, we normally call it as infrastructure as a service. Infrastructure is nothing but the way what physical data centers we own in an organization, similar architecture or similar infrastructure we will own in the service provider. Service provider will allocate you 2 or 3 switches, and service provider will allocate you a router. Service provider will provide you one internet connection. Service provider will give you server applications and a server, and on top of the server they will give you the virtual machines or the server application. Okay, so capex, so capital investment to deploy the data center is not there. Management, so again power or whatever may be the expenses we try to do it for the operational opex, even that one also we don't have to do that. So just to own number of servers, number of switches, number of routers, number of internet connection, we will have to pay for that. So we are owning.
Okay, you mean to say that, like for example, if we have to, if I need some requirement, like I have to set up some, I have to do some implementation, or I have a requirement of project, I have to do some setup, wherein I have to buy routers, switches, or whatever the proxies and all I need to, which required for an implementation, wherein I have to put a capital for it and it will take time. So wherein I would be asking provider to set up all these things, I would be paying a rent for it.
Exactly, yeah. You are operating your data center or your infrastructure resources on a customer's, I mean, on a service provider's place.
Okay. So similarly, okay, like SaaS, it's like a vendor would be providing in a software. I mean, the application they are giving it. Here, it could be an infrastructure they are giving it. So they will give all the hardware, power, everything they will give it. So and they maintain it or we maintain it.
No, mostly like again, it depends on the money only. I
Okay.
also can dedicate some resources or some of their resources to manage your infrastructure, or
Mm.
you can tell that you have your resources. ISP they don't have to involve for management, so it's like cost only.
Okay. 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 Okay.
So
So
software as a service, well, they will not give you routers, they will not give you switches, they will not give you internet connection, they will not give you any network resource or any infrastructure as a network resource. What they will give you, they will give one virtual machine, or they will give you like this is your application server, and top of that, you wanted to run Microsoft Office 365 or web server or DNS server or voice server. So what you just need to have only the server, and for the server you pay for it.
okay.
Yeah, so Parthiv, that is for the server hosting, application hosting. Okay, here we are discussing about the network, right? Like edge router and all this stuff also will be
Purchased from which will be hosted on the provider network as an infrastructure as a service.
provider. No, how can you? So that should be in the customer premise, right?
Okay, so people are like the people are rich, like you can invest your own data center. Maybe simple the middle companies, and then the people they don't have important traffic or prioritized traffic, so they don't have to go with their local data center, so they can own their data center in the cloud itself through the providers. So typically, like sensitivity of the data matters.
No,
Yeah, Rudresh, even
got
for
it, got
us, it's not in the IBM data centers we have for our entire SD-WAN for globally IBM it is with Equinix.
it.
It's
Yeah.
Equinix is a third party data centers where we just put our infrastructure. That's it.
Mm.
Yeah.
Okay.
Yeah, in this case, because what happened, if you want to set up your data center in Bangalore, Bangalore may give you maybe 10 Mbps link for your WAN connection. But if this is provided in the cloud, maybe the cloud provider maybe in US or UK or any other region, maybe even in India also. But that fellow might provide you for the same cost 1 gig link also. So it depends like how fast the provider network or the cloud provider network connected with their backbone. And
Okay.
you have to have resources. You have to take power from the local body, and then you'll have to take engineers resources to manage it. But nothing is available. Just you pay the money. Every infrastructure devices will be available on the ISPs, and you make your RDPs or you make your SSH. You just manage your devices. That's what we do.
Similarly, we can consider our training itself. I mean, we have got our rack rentals. So it's like enter one is giving the physical racks. I mean the infrastructure. Else, if we have to demonstrate it, so we need MPLS link and then internet link we need, and we need router,
Yes.
everything. So to demonstrate. So rather than that, we are just bought the rack rentals, which nothing but that provider has given the rack
We have,
to practice it.
yeah. So they have given us infrastructure as a service.
Yeah, same thing.
Fine. Any other questions?
Guys, any questions on infrastructure as a service or a software as a service or anything on the cloud specific?
Okay, thank you.
No, Naveen, thank you.
Adresh?
Yeah, I'm fine here. I got it.
Okay,
Yeah.
all right. This is the two options basically supported from viptela for the so cloud-based network reachabilities. Configurations could be, okay, so we have to go to the settings first. So by default, cloud and RAM for SaaS and then IaaS is disabled. So we can go back to administration and then settings. And this is our vManage general settings. Organization name, vbound email notifications banner. There we can choose with so here we can find cloud on RAM for SaaS is by default disabled. Once we enable, then we are allowed to create applications, we are allowed to create sites, and we are allowed to map them. So this application or in this site could be connected with the direct internet accesses or direct internet access and gateways definition. So one device or the place where the physical or the data center gateway devices are present, we will configure them as a gateway. So I will enable this. Enabled. Save this. So we can find it cloud on ramp for SaaS is enabled. Then we will come back to the configuration itself. So now you remember devices. This is for the whitelisting. Tls Ssl for proxy. If you want to enable proxy, these devices will act as a proxy devices. Certificates. This is like a network design. And the templates, device configuration, policies, centralized and then localized data control policies. Security, we can enable L4, L7 security features. Now we could find other options like cloud and RAM for SaaS and cloud and RAM for IaaS. So cloud and RAM for colocation, this is not needed at this moment. It is going to go to some collaboration. So cloud and RAM for SaaS, cloud and RAM for IaaS. If we choose here, we will define the applications, we will define the site, or we define the gateway, and we will enforce them through the policies. Okay, or else cloud and RAM for SaaS, it should be connected to a service provider. So it will point to AWS or Microsoft Azure. I mean, the place where we are trying to take our infrastructure connection, and we'll take the physical informations from there. So at this moment, we will not be able to configure the IaaS, but I can show you the option. But SaaS and specific configuration options, I will show you that. So we don't have any place to test this information, but I can tell you like what are the configurations and what are the steps we are supposed to do. I go with the cloud and RAM for SaaS. So this will give a dashboard with the information. Welcome to Cloud on RAM for SaaS. Cloud on RAM for SaaS is now enabled. To start using Cloud on RAM for SaaS services, we have to complete these 3 steps. The steps are nothing but we will define application. So what application has to go through direct internet connections or through gateway connection, or from which VPN the traffic has to go to the respective, for example, the network. Okay, now similarly, simply like they are defining application and VPNs. So now in this case, what happened? You can take VPN1. In VPN1, Office 365, Google application, Microsoft application, Facebook. So we will create the classification based on application and VPNs. Then we have to tell these applications and VPNs, they are enforced from which sites. So which sites are enabled with direct internet access or cloud services. Okay, sites, and then we need to configure gateway and direct internet access sites. So the place where gateways are present and the sites they are going to use direct internet access. By mapping these 3 configuration, and we will do that. So the traffic on what advantages from what sites, and then what kind of connections we are going to enable it, direct internet access or the gateways. Okay. So there will be like a empty dashboard, and we do see an option called manage cloud on RAM for SaaS. Once you click here, this will give you an option. So applications, we can create the application be permitted, and then client sites, so where the traffic is expected, and whether we wanted to configure direct internet access sites and the gateways, or anyone you want to give only gateway, you can choose this, or you want to give only direct internet access or multiple direct internet access, you can do, or we want to do both, one here and then one here. So any combinations we can do it. So as I told you, sites with only direct internet access, sites with only the gateway, sites with both internet and then gateway configurations. So we can choose application. So here applications will come, for example, Amazon AWS. This is expected from VPN1. In VPN1, if Amazon AWS application comes in, and then Office 365 comes, and then Dropbox comes over here. So in VPN1, if this, or you can add more applications as well, and they are recognized. So Vantages will recognize this application, and we wanted to add more applications also, you can add it by giving these values. So applications are added. Then you can go back to the client site. So attach site. So there are no applications added. Please specify the applications view. So now site not connected here. So now we can go back to direct internet access site. Attach direct internet access site. Okay, so we don't have options here. Devices are not connected. That's why it's not enabling it. Even in the gateways, this will tell like attach gateways. And then this will get enable application, Oracle or Amazon. I save it. I did not save it. Then Office 365, and then Dropbox. Under VPN1, and save the changes. The application list is saved in the vManage, and then I can go to the client site, attach site. So now we could find site number 20, site number 30. So at this moment, no options are enabled here. If devices are present, if physical boxes are present over here, and then we can choose for site number 20, we can enable cloud on RAM. So site number 20, first site, second site, you can attach it. So we will have to the application, and these applications are attached with the site. This is the place we are attaching the site. So meaning that on this site, okay, we site number 20 branch VE2, for branch VE2 on VE2 router in VPN1, and if application traffics for Office 365 or Dropbox or the AWS traffic. So this is categorized. Okay, once this is categorized, and it should be updated to, for example, gateways or direct internet access site. So we can tell like which devices are going to have what direct internet access site. So direct internet access configuration, you can do it. And gateway to be deployed, you can configure the gateway, attach gateways. It will tell you like what devices we are going to provide it. So now here branch 20, while you're attaching, in the next step that will ask you like branch VE1, branch VE2, branch VE2, like the devices will come in these specific places. Okay, so this is the place where we can create our application, we can create our sites, and we can create our gateways and then direct internet access sites. So that once the mapping and then policies are done, then obviously like a Cloud Express on the SaaS communication towards the WAN edges will be enforced. Then same way to configure the IaaS configuration, since like we don't have a reachability, but I can show this. So no cloud instances are added. So add to get started. So we have to add the cloud instance. So at least 2 unused WAN edge devices with template attached should be available. Okay, once we attach 2 WAN edges, and then you can proceed with it. So these WAN edges will have the IaaS based network communication. That is cloud based WAN edges. 2 WAN edges connected or placed on the WAN edges, so that these devices will be provisioned with its unique background or behind configurations. All the devices are used in the site and they are like added, and we need to integrate with the cloud as well. Inter-site connections problem. Okay, all right. So there are 2 tabs for you, like cloud and RAM for SaaS and then cloud and RAM for IaaS. Based on that, cloud-based connections for SaaS applications, for infrastructure as a service, infrastructure applications, we can apply our settings. Okay. Any questions, any doubts on this? I will discuss. If not, we will go to the next step, next configuration.
Yeah, I'm fine. Man. Thank you.
Okay. Okay. Okay, right. So the next information what we discuss is about high availability. In terms of high availability, so we have controllers and forwarding devices, controllers redundancy, and WAN edges redundancy. So up to now, we discussed WAN edge in branch 1, WAN edge in branch 2. So single WAN edge and then single WAN edge infrastructure, we are discussing about it. But in the real-time scenario, primary and then secondary are 2 devices. So 2 devices will establish a VPN tunnel with other WAN edges, and there will be 2 tunnels per devices, like 4 tunnels. Out of 4 tunnels, best performing tunnel will be calculated by the applications. So WAN edges level redundancy, controller level redundancy, how do we configure and then how do we map them? So these related informations, we will talk about that now. Okay, so the first option is controller redundancy as a VBond. So VBond is the orchestrator, and VBond orchestrators have a whole view of the devices allowed on the network. So based on the whitelisted devices entry, and all the devices are permitted in the fabric. So multiple VBonds can be deployed for function and geographic redundancy. So we are maintaining one VBond. All the geographic devices are going to be authenticated by this VBond for the participation of the fabric. Instead, we can deploy multiple VBonds, and these VBonds can be with multiple geographic location, and depends on the local or best shortest path available to the vBond, the devices can talk with it. So we just pick vBond IP address via DNS. In this case, by introducing multiple vBond, so vBond 1, vBond 2 in region A, vBond 3, vBond 4 in region B. So what we can do is, while we are configuring the WAN edges, so we are supposed to give the vBond IP address. So now vBond, and we can give it as vbond.ibm.com. So we can just give a fully qualified domain name. So in our lab, we just configure vbound.demo.local. So similarly, like we can give a fully qualified domain name. So now in the fully qualified domain name or in the DNS infrastructure, we can tell that if any query comes to vbound.demo.ibm.com, and this is resolved to first IP address, second IP address, third IP address, fourth IP address. So we do maintain 4 IP address responses for the DNS. In this case, when the first DNS query comes or when the first device comes, then response will be for the first vBond, then second one, third one, fourth one. So based on the DNS round robin process, we will tell that this resolution for the vbond.ibm.com, the IP address will be given for each vBond devices. So VH picks vBonds via DNS, and DNS will perform the load balancing logic and round robin process. Based on the round robin process, it can tell you the information towards to the local, or it can give the information about to the local or the nearest vBond IP address. VH will try first entry, then second, and so on. And VH to vBond, as we are familiar, VH to vBond connection is temporary. They are established once the required informations are communicated, tunnels are terminated, and we call it as stateless, which is UDP based. And vBond maintains view of load on vSmart and delivers list of vSmarts to use it. Like all the vManages and then all the vSmart informations are distributed from vBond to the end devices. Simply like by introducing the load balancing algorithm, we can achieve the like various vBonds are reachable with each other. If the people or if the infrastructure is too good, instead of DNS, public DNS server, we can introduce local load balancers. For example, in Big IP, we do have LTM and GTM infrastructure. Okay, in case of LTM and then GTM infrastructure, you can specify if somebody is trying to access vbond.ibm.com. In the GTM, you can tell depends on the geolocation. The WAN edges are coming from India. So in India, any or nearby India, any vBonds are present, vBond GTM will give a response towards to it. Or we can specify like a load balancing algorithm. Depends on the load balancing algorithm, round robin process, or it can be rewritten to LTM. So anywhere you can place it out. But by introducing the GTM or by introducing the DNS, based on the round robin DNS query resolution, multiple vBonds can be reachable to these end devices. Even if one vBond goes down, not a problem. The devices will be given with a different vBond IP address and they will be authenticated and they will be placed.
Sorry, what is LTM and GTM?
They're all load balancers.
Load balance, FI load balancers, one local traffic manager and global traffic manager.
This is FI product, Big IP FI product.
Local traffic manager.
Yep. So local traffic manager, global.
You have yeah, it's load balancers. You have separate trainings for LTM and GTM. It's separate papers.
Okay.
Okay. Sorry, there is a background noise from my side. Naveen, just allow me a minute. I will close my door.
No issues.
So V-bound redundancy is managed with the help of DNS and DNS name resolutions. And when we talk about vmanage, so vmanage is the place all of our configuration resides. Our devices upload whitelisted devices information, uh, install certificate and uncertificate information, templates, policies, security related configuration. So any configuration we tried to do that on the vmanage, and vmanage stores it local, and these configurations can be synchronized with other devices as well. So we do have active group and then standby group. So active group will be presented with read and write. So all this is like this is with read and write, and the standby group is with only read only access. So read only access in a sense like data and configurations are synchronized. Apart from that, we will not be able to make any local changes. So we manage servers form a cluster for redundancy and high availability. So all servers in the cluster acts as active nodes. So the primary cluster devices active in a sense all the devices are with read and write condition. So all members of the cluster must be in the same DC or metro area. So the latency of the communication for the primary group or the active group will be very less. And then for geo redundancy, secondary groups are operated and they are going to be in the standby mode. It will be in the read only stage, and there will be no cluster configurations required, but database replication between the sites are configured. So any configuration we try to do it on the active group with active vmanages of about 3, and these configurations are synchronized automatically to other 3 devices on the standby group. Similarly, like we do have like failover issues, like loss of vmanage server has no impact on fabric operation. Even if all vmanages go down, we don't have any issues because new changes or future changes will not be carried, and no statistics informations will be collected. But apart from that, all vsmarts, all vedges receive the configuration from vmanage using the last known state of the configuration. They will up and they will work into the network. So until the devices or vmanages are troubleshooted, new changes we will not be able to enforce it, but still the devices will keep the local copy of the configuration and they will work into the network. Any data plane communication or control plane communication, VPN tunneling, VPN tunnel logic, policy enforcement, everything will go as expected.
Still, that time also, if manage goes down, and we can do local changes, right? So
Yeah, we can do local changes and then we can be able to manage or we can be able to retain the network. But it's like least condition only. So no organization is going to make that, or no is going to be with the lenient that all V managers are going to go down. No way at all. So when they buy the V manage, they will buy V manage in one geo location with one provider. Second, we manage with the second provider network, and then third one will be with a different location. So even if one location goes down, then remaining 2 locations will work and then they will manage the traffic.
okay.
So net downtime will be almost zero.
Mostly like if at least one vmanage is available, downtime is 0. Because this is all available on the cloud, right? Public cloud. So obviously cloud provider network may not go down. Even if one provider goes down and other provider and their own vmanages will serve the to the fabric.
Okay.
So we have our infrastructure. We have our own data center. On the data center, we have deployed our ESXi. On top of that, we placed our vManagers. Then, in case our data center outage or data center server failure or ESXi, sometimes vManage may not be available or vManage may go down. Even in that situation, also best practice: don't deploy all vmanage is in the same ESXi. We deploy one vmanage in an ESXi, then we choose different ESXi, and then we try to deploy it. So 3 or 4 servers, and then 3 servers, like each virtual machine, like each one will be with its unique vmanage. Then we maintain the connection to the specific network. Even that kind of situation also we try to manage it. Okay. So since like we have 3 vmanages, at least one vmanage is available, our network will be like will not be with any impact. Even if all vmanage goes down also, we don't have any impact on it. And then we have vsmart, the controller redundancy for the control. vSmart controllers exchange OMP messages and have a identical view of the SD-WAN fabric. V8 routers connect up to 3 vSmart controllers for redundancy. So any V8 can connect with the 3 routers, some 3 vSmart, but by default enabled is 2. So even you can remember in our lab exercises, it is connecting to 2 V8s, 2 vSmarts only. If you go to any vantage, all all 3 vSmarts up and then running, it is showing only 2. So why showing only 2? Because it's a default behavior. So 2 OMP sessions are by default enabled, and a maximum of 3 devices here can be able to connect it. So single vSmart controller failure has no impact because the control plane, OMP adjacency, T-log, routes, everything will be available through the other vSmart available. If all vSmart, if no vSmart is available, then entire network will be down. If all vSmart controls fail or become unreachable, remember V8 routers will continue open on a last known good state. The OMP routes, T routes will be launched, and this is maintained only up to the hold interval. Suppose 10 seconds is hold interval. In 10 seconds, no new OMP update comes in. Devices will be announced as the down. And entries, local VPN entries will be deleted. If OMP routes are available, no data transmission will take place. Then route no exchange, keys no exchange, entire network will be down. So updates to IP address are reachability, no IPsec keys, and if we manage pushes policies and applies policies, they will not be communicated to any other address. So one vSmart should be up, and then if vSmart goes down, this is its entire network or entire device will forward the traffic to other device over the path. So one we to be available. Now we have ER region and M region. So we have vBond and 2 vSmart. EMEA region with 1 vBond, 2 vSmarts, and in APAC vBond and 2 vSmarts. So on the vmanage, on the v edges, if you could remember, under the system, whenever we are typing the command called system, and we give the system IP address, then organization name, and then we give controller group list. You can find this is the command we just maintain in our lab. We maintain the controller group list number is 10. It's nothing but okay. We created the vSmart group. Whenever we are initializing, this is like a controller list ID. So here in vSmart list ID, and which is configured with 1, and then this place as 3. So whenever we are mentioning the configuration in this place, controller list, so 1, 2, 3. So this router is created with controller group ID or group list is 1 and 2. It's nothing but it can maintain connection towards in group number 1 vSmarts are available, then it can attempt to form the connection session with group number 2. In group number 1 we have 2 devices, group number 2 2 devices. Okay, first OMP here and then second OMP. If one OMP goes down, then one OMP session with the group number 1 and second OMP session with group number 2. So this will try to take the routing from vSmart 1. In case these two devices fails, this will take the routing from the group number 2 devices. So primary group and then secondary group for controller communication with vSmart, we would configure under the controller group list. So this is very important. Whenever we are creating the controller, at least one controller should be up and then running. So then only WAN edges, the control plane information fabric will be operational. So just to maintain at least one vSmart reachable to WAN edges, and we do have an option of creating the controller group list. And in controller group list, primary group and then secondary or active group and then standby group, we can place it. And all vSmart communication will take place to active vSmart. In case of vSmart failures in the active group, then they will be connected to secondary or the standby group. So this is the controller redundancy with vSmart from WAN edges. So vBones are enabled with redundancy communication using DNS infrastructure. And then we manage basically by configuring the cluster, active cluster and then standby cluster. We maintain the redundancy for that. For vSmart, we can create the vSmart group and at the WAN edges by specifying what vSmart group the devices should communicate. And then the devices will maintain their own adjacency for OMP communication. That one, at least one redundancy or one OMP adjacency is maintained. And then WAN edges. So WAN edges are routers. How routers are router-based redundancy provided to the site. It may be a data center location or maybe a branch location or maybe campus and then specific site location. So various option comes in because WAN edges, we can have two devices as a standard practice, and WAN edges can have multiple transport connection or with cost cutting single transport connection or with mix of both the combination. So depends on the number of connections terminated into the branch or to the site, then redundancy can be discussed. So some of the case studies or some of the redundancy option we will discuss it. The first option is meshed. In case of meshed redundancy, so now what happened? We maintain WAN edge 1 and then WAN edge 2, and there are two transport. WAN edge 1 has internet connection, WAN edge 2 also has MPLS, and WAN edge 2 with the internet and then MPLS. So that means from the service provider, in total 4 connections we purchased it. So 4 circuits. So cost of the circuit, circuits are high, but still what happens here is we do have a redundancy of it. So from here, first VPN tunnel, second VPN tunnel, third VPN tunnel, fourth VPN tunnel. So to every WAN edges, we can maintain the tunnels towards to it. So V-edge routers are directly connected to all the transport. So SD-WAN tunnels are built through all directly connected transport. So this is the first option. What is the benefit? Back we are going to get it. So when we maintain two devices with 4 circuits, so in case the link failure, so device number 1, device number 2, in case the link failure, one link failure, there will be 2 tunnels and then 2 circuits available to the specific site. And we can say like MPLS connection, primary MPLS connection, secondary internet connection, primary. There are 3 connections available. Using 3 tunnels, best tunnel will be selected and then traffic will come into the network. Then second option, if the service provider fails, service provider connection goes, or if the service provider network failure takes place, Now the WAN edges to other service provider or other transport will function. So two transport will be available. I mean, two tunnels will be available. So using MPLS on router 1 and then router 2, that inbound traffic and then outbound traffic will be handled. In case of router failure, and these routers, so two tunnels will be down and then two tunnels will handle the site traffic. So meaning that when we purchase 4 connections, so any situation, one side circuit failure or one side transport failure or one side router failure, minimum of 2 tunnels will be presented to the side and then for site data transmissions. Cost of implementation or cost of the connection will be high, but we will have a good redundancy options using this behavior. And then we go with the next option. So when we go with the next option, this is called as L2 switch redundancy. Okay, both are similar, but what happens, we are going to use a layer 2 switch in middle. So service provider has given one connection which is terminated to an L2 switch. From the ISP, we have taken 2 IP address, one IP address for device number 1, second IP address for device number 2. So 2 devices are reaching to internet using circuit number 1. And then similarly, we do have a second MPLS single connection, and using 2 IP addresses, they are connected to the provider network. So here we have taken 2 connections. There are 2 circuits purchased. So 2 circuits purchased, and then 4 IPs, and we purchased it. So 4 IPs and then 2 circuits. In this case, again, similar designs we try to have. First tunnel and then second tunnel, third tunnel and then fourth tunnel. So we try to get 4 tunnel because we have 4 independent IP addresses. So VH routers are directly connected to all transports through L2 switch. SD-WAN tunnels are built through all directly connected transports. Tunnel will be created in this manner. Look at here. So first device, it forms tunnel number 1 through internet, and tunnel number 2 to second device internet, again MPLS and then MPLS. There are 4 tunnels built. In case of this link failure, obviously like this link is shared between 2 devices, 2 tunnels will go down, 2 tunnels will be connected. In case of transport failure, again 2 tunnels will go down and then 2 tunnels will be connected. Here, in case of router failure, so obviously like 2 tunnels will go down, again 2 tunnels will be connected into the network. Even this is also a good option. So 4 tunnels are built. In any situation, 2 tunnels will be down and then 2 tunnels will be retained for the transmission into, as well as transmission from the site into the fabric. Any questions here on this too?
No. With any questions?
No.
Okay, all right. Now we go with the third option. Third option is called as T-lock extension. In T-lock extension, we are purchasing one circuit and each location. Okay, so we don't purchase 2 connections per location. We purchase one connection to internet and then one connection to MPLS, but we don't maintain any L2 switch in middle. Okay, instead, we are going to maintain dedicated links, one dedicated link here and then second dedicated link here. So the idea here, for device number 1, it has one connection to internet dedicated, and then second connection, this link will be allocated for this device to talk to MPLS. So this device will talk to MPLS via a peering device. Same way, this device, so device number 2 will be connected with MPLS direct connection, and this shares this connection towards to this particular devices. Okay, so every device will have one direct connection and one peer link connected to other transport. The good point over here, service provider link is directly terminated, directly terminated. In middle, we will have to maintain two connection. Between two connection, one will be connected to this guy and one will be connected to this specific device. Even this is most of the customers utilized type T-lock extension type. The way like cost of the connection is bit limited, like one connection per devices, and these devices are directly connected to the transport, and also they are directly connected with each other. If you are connecting in this way, this logic we normally call it as transport locator extension or T-lock extension. So each VH router is connected to a given transport, and SD-WAN tunnels are built through local and remote endpoints. So first tunnel towards to internet, and second tunnel towards to its extended port towards to MPLS. Similarly here, first tunnel to MPLS, and then second tunnel from his dedicated port or the extended port to internet. Okay, so now we can find a number of tunnels. In case like a device 1, device 2. So it has got the first tunnel, and then second tunnel, third tunnel, and then fourth tunnel. In case of the link failure, if this link goes down, this connection or this device VPN tunnel will go down. This connection we have extended through this port. Obviously, this one also will go down. So both the devices will lose the connection or tunnel to internet. Then direct MPLS tunnel as well as T-lock extended tunnel for this device. Two tunnels will function into the network. Same thing will happen for transport failure. In case service provider network is failure, two tunnels will go down, and then two tunnels will be connected to MPLS. In case router failure, obviously three tunnels will go down. One tunnel with direct MPLS will function into the network. So in case of router failure, at least one tunnel or minimum of one tunnel will come in picture. So the advantage, two connections from the provider we purchased, and we maintained as per our level as much as possible, like two redundancy or two tunnels into the site. But in case of device failure, one tunnel towards the specific site. That is the reachability connection. We do maintain it. This option is not suitable for a data center, and this can be a suitable solution for branches or campuses or small regions where we don't have to buy a layer to switch, we don't have to buy higher circuit, we buy only the WAN circuit, WAN edges, two connections, terminate, T-lock extension, and then associated configuration we do to that. And the next is site level redundancy. Suppose from the transport, so the redundancy what we have discussed. Okay, so from the routers, transport level redundancy, from the router talking to MPLS or talking to internet, again MPLS internet. So when we have got full mesh or meshed connection, or we go with the T-lock extension option, or the third option is connected through switching. This is like providing you the transport level redundancy. And then we do have controller redundancy, as I told you, by specifying the controller group ID and then controller group list. So this will tell to WAN edges to vSmart communication. So we'll try to enable it. Now,
Parthiban, what exactly this TLOC extension does in case of the failure? So you have shown it whether we can have a failure of a circuit, or whether we can have a failure of router hardware itself, or we can have a failure of any of the POP like MPLS or internet. So by configuring the TLOC extension, so how exactly it works behind the scenes?
okay, now here, this is the T-lock extension network. So what we have done is we have router 1 and then router 2. So between them, T-lock extended interfaces are configured. So meaning that there are 4 tunnels built. If this is available, if both the transports are available, tunnel 1, tunnel 2, tunnel 3, tunnel 4. There are 4 tunnels will run. Suppose if ISP to the router, if this connection goes down, what happened through this connection only? We built this tunnel. This tunnel will go.
How 4 tunnels will be there between VH1 and VH2? I mean, between these routers.
Okay, so this place you take one IP address. Okay, on the place where internet is connected, we try to take an IP. Let's say 25.0.0.1. and
Okay,
all
okay.
MPLS connected, I will try to take 45.0.0.2, so 2 IP
Okay.
address. So now what
Okay.
we will make 2 connections. This is called shared connections. Let's say I'm trying to take 26.0.0.1 and here 26.0.0.2. Okay,
So
so
you mean to say that's cross connections, like because we just cannot directly connect it.
yeah,
So we assume that this is router 1 and router 2. So router 1 would be having one link to MPLS, and then this one router 2 also will have one link to internet. So then it will be 4,
yeah,
like that.
they will be crossed like this. Yes. Okay, now you can find there are like 2 cross connections. So first cross connection is 26.0.0.1, 26.0.0.2. So now what this router will do, 25.0.0.1 is a public IP address to connect with internet, and then we have another link 26.0.0.1, 26.0.2. So this 26.0.0.2 will be NATed into 25.0.0.1 and will be permitted to public network. Basically, NATing will come in picture here. You got it?
Matting happens automatically, or we have to do it. I mean, as it forms 4 tunnels. I mean, as
No,
4 T-locks. Yeah.
yeah, this is part of the TLOC configuration. In TLOC configuration, what we do, we will choose, this is the extended port, and this extended port goes to this physical port, that is service provider connected port. Any traffic comes from this extended port will be NAT translated to 25.0.0.1. It goes like this. You got it or still confused?
Got it, but only the NAT portion I am little confused. So I mean, I got it. So there are 4 things. One is that. 1 second.
Okay, so remember, now from internet, we have taken one connection, single connection. So ISP has provided one public IP address. They provided only this public IP address. So 25.0.0.1, meaning that if anybody uses 25.0.0.1, then public network reachability will be provided. Suppose if this device is extending this connection 26.0.0.2, if there is a traffic goes into internet, it goes, but return traffic won't come because he is expecting the traffic only from 25.0.0.1. So as a default behavior for the TLOC extension, we configure NAT. So this port, any traffic comes like 26.0.0.2, it comes in. This will be masked to 25.0.0.1 and then permitted. So the other devices, suppose if you have got, we'll have another device on the network. When this is forming the VPN tunnel, it says it has first VPN tunnel to 25.0.0.1, and both public and private IP addresses are 25.0.0.1 itself. Now it forms the second VPN tunnel to the same IP address, but the private IP address would be 26.0.0.2. So this will differentiate it. There are 2 tunnels, one tunnel to 25.0.0.1 public IP, second tunnel to 25.0.0.1, but to 26.0.0.2 IP address. So 2 tunnels will be possible. The physical data will go in this path itself. You got it?
Yeah, I mean, yeah. So I got it. See, like, probably I don't know how to.
Yeah, when this is connecting, this is the third tunnel, and the fourth tunnel will be connected through this physical port into this place. This is how 4 tunnels are terminated.
Yeah, that I understood. But why really the NAT is required here is what? Because of the public and private?
Yeah, because of the public and then private. Apart from that, nothing else.
Okay, okay.
Otherwise, what happen? You will have to purchase minimum of 8 addresses, because when we are giving 45.0.0.2, 45.0.0.1 will come here, and this is like /30 mask. If you assign a subnet in one physical port, same subnet you cannot assign it here. So you'll have to give it to a separate subnet itself. So this place it will come with 45.0.0.0/30. This is a subnet you try to do, and in this place 45.0.0.4/30. If you have this scenario, even you don't need NAT, directly using public IP, you can permit it. But if you have taken only one IP address, then NAT is implemented here. It's all like public to private communication, but nothing else.
So considering if we have MPLS in internet link, so MPLS being having a private and internet having this thing. So if one link goes down, so okay, it needs to get exchanged. So okay, got it.
Like this is the cheapest solution, what you can say. Like we take one connection and then one IP address from the when purchasing IP also cost involved, right? So we are taking one connection and then one IP address, but maintaining our internal connections, internal private IP addressing, and we are trying to lead two more tunnels towards the external locations.
Okay, okay.
But all the situations we have a benefit of it. Even if the provider goes down, the link goes down. If the link goes down, so this tunnel through internet will go down, and this internet is shared here. Obviously, this tunnel also will go down. If MPLS goes down, same condition. If complete transport is failure, obviously like one link, one tunnel will go down. Extended link also will go down. One tunnel or one provider will maintain two tunnels to this. If complete device fails, the extended link also will go down. One provider link also. That means three tunnels will go down, but one tunnel will provide the reachability to the site.
Okay. Probably just let me share my screen 1 second. So if you just explain me in that, so it will be really good because
Yeah.
this is 1 second. Sorry.
Yeah, go ahead.
Are you able to see my screen?
Yes.
So we have multiple scenarios here. So considering, see, this is the SD-WAN routers in the last box. Okay. So this one. Oh, where can I get the pen and this thing to draw? Okay. Yeah.
This is extension only. Yeah.
Yeah, this is the SD-WAN routers. Okay, this is all
Yeah, can
below.
you
These are on the LAN.
maximize
Okay.
the screen? Can you maximize the screen? The
1
PPT.
second. Yeah, sure.
You close the annotation, then it will.
You got it?
Yeah.
So this is the SD-WAN routers actually. Okay, so and this is one is connected to MPLS and this is connected to internet service, internet links. So this is all coming from the LAN segments. Okay, so considering this S1, S2 or MPLS based traffic, I told you, right? So there are traffic based on MPLS. Also, there are traffic may generate. For example, assume that a end user has generated the traffic for both the internet as well as MPLS, and you are getting like this. So this and all still we have it. These are all devices interconnected. So actually, if you see the SD-WAN routers are not interconnected actually, but you have say one link to internet thing, and you have one link to MPLS, vice versa. I mean, both routers will have each link, one link to MPLS and one link to internet from a redundancy perspective. Okay. So here it says that S1 and S2 are sessions destined over MPLS, while S3 and S4 marked are using internet. A session is defined as a unique pair of source and destination IP address. All traffic is routed via active border access. So leave that active SD-WAN CA. Active CA is a tunnel originator terminal while backup SD-WAN is passed through all the tunnels I'll come across. So 1 second, let me just go to the next slide. I think so there the failure scenarios is there, I believe. 1 second. Yeah. Yeah. See here. So assume that SD-WAN routers, one router is failed. So it says that TLOC extensions or shared physical crosslink. So this is what I'm quite confused. So what exactly and how it works?
Okay, this topology is a combination of two. So in my picture, the first scenario I made it is meshed, in the sense WAN edge 1 will have two connections. WAN edge 2 will have 2 connection. In scenario 3, TLOC extension, each WAN edge has 1 connection. But your network is designed with both the combinations. So WAN edges are with full meshed connection as well as TLOC extensions.
Yeah.
Can you go back to the previous slide?
Yeah.
So in this situation, what happened? We have S1, right? The place where it is connected, S1 MPLS service. Using S1 IP address, first tunnel will be built.
Okay.
Using S3 Internet IP, second tunnel will be built to this device.
Okay, first SD-WAN router A.
Yeah. Right? And for SD-WAN CEA, we have got S2 and then S4. Okay, out of S2 and then S4, only one it can use it, other one will use the other link. So that means S2, S4. Suppose if this is using S4, using S4, it will form the third VPN tunnel through internet path.
Okay, because SD-WAN router has a direct connectivity, one link to MPLS and one link to internet service provider only, right?
Yeah,
so,
I will request, can you provide the annotation access?
Yeah, please. Yeah.
Okay, now what happens? Using this IP, first tunnel will be built.
Okay.
And then using the second IP, that is internet IP, second tunnel will be built.
Okay.
Then third tunnel will come to internet path using this internet IP address itself. So that means this WAN edge will have the first tunnel using this IP, second tunnel using this IP, third tunnel using this IP address. This is like 3 tunnels. And same thing will happen for this box as well.
Yeah, that third and fourth tunnel, so it is building with SD-WAN routers, so but it is not physically connected, right?
This is physically connected. These links are physically connected.
But CE router and CEB is physically connected there.
Yeah, they are physically connected. CEA and CEB, that's what you mean to say?
Yeah.
This is like TLOC extension. TLOC extension over shared physical crosslink. It's a physical link. It's a dedicated physical link between these devices.
Okay. So that's what I was just thinking, whether that's a physical connectivity or it's like, I mean.
No, it's a
physical.
It's a dedicated physical connection.
Okay.
Now even the WAN edge B, according to WAN edge perspective, through MPLS, there will be first tunnel, and using internet, there will be second tunnel, and using this TLOC extension port, it will go to the third tunnel. So each device will be with three tunnels.
Okay, now I got it. So because I was just thinking, now I understood that 4 tunnels will form, because I was in assumption that the 2 links, that S4 and S2, what it is showing in the diagram is I thought it's not a physical connectivity, because normally the CE routers in the SD-WAN concept, it's not physically connected. So that is what I got conscious. I thought these two are not directly connected, I thought. Okay. Now I understood. Yeah.
Okay.
Yeah. So because they just given other scenarios only, like same what you have shown in the diagram, like a circuit failure, a hardware failure, a link failure, how traffic will get just diverted from, if CE router goes down, how traffic will shift to CEB router. What if MPLS goes down, how traffic will shift over to this thing.
That's correct. Yeah.
Okay.
Now you go to the next slide, and if you read them, you can clearly identify like router failure or the tunnel failure or the circuit failure. You can check how many circuits.
This now I understood. Like, I mean, they have given so many scenarios. Like, now I understood. Say this link goes down, so how it happens. This link goes down, how it happens, and this link goes down, how it happens. That link goes down, how it happens. Here in the infrastructure, before the SD-WAN itself, what if goes down, traffic will shift. So from all perspective they have given. So now I got it anyway. Now it's clear. Yeah. Thank you so much.
You can stop the share.
Yeah, I did it.
So TLOC extension is another option. Okay, so here now you can find first topology as meshed. So this is what the first scenario, and second scenario with the switches. This is not available for you. And then third option is TLOC extension. So in your presentation, it was like this. So this is connected to MPLS. This is connected to here. So one connection here, second connection here, and one here. And then this is how it like presented. So in total, 6 physical connections. Okay. Now the tunnels are built till the WAN edges. Now how WAN edges are going to talk to the LAN boundary? We have core switches and we have core routers connected in the site or the data center. So what kind of redundancy we try to enable it? So at the site level redundancy, WAN edges are supported with VRRP. So first half redundancy protocol. If you go with viptela devices, since like VRRP is open standard, VRRP supported. viptela devices, VEdges will not support for HSRP. But Cisco devices, well, we choose C edges. We can choose either HSRP based configuration or VRRP based configuration. If not, we wanted to run with a routing protocol. So we can run again the service VPN side OSPF or BGP routing protocol with LAN based routers. And based on the routing protocol policies or the route distributions, we can choose what path is going to be the best path towards to it. So any traffic coming to WAN edge 1, it goes over its respective tunnel. Any traffic coming to WAN edge number 2, the traffic goes to the respective tunnel of each devices. So transport level redundancy, site level redundancy with the VRRP and then routing protocol. And then network level redundancy like transport 1 and then transport 2. This is like could be possible with the help of color restrict or color with no restrict option. So tunnels can be created using multiple paths and then multiple transport intercolor communication, everything. We can control that as well. Controller redundancy. So with vSmart, okay, primary group and then secondary group or active group and then standby group in the controller group list. By mentioning that, the communications or the redundancy will be managed. So vEdges will provide redundancy for every site, branch or the data center, even to the controller level, to the transport level, to the next next head end level, as well as at the site level. So controller
Okay.
and then regional affinity options, which we point we wanted to discuss as part of the redundancy. So redundancy for the controllers, redundancy for the WAN edges. Any questions on the redundancy we will discuss. Otherwise, we have one more lab for TLOC extension. So in our lab exercises.
So what is that for TLOC rewrite, Parthiban?
TLOC rewrite is like policies. So the next of IP address, the devices will modify. Service functions, you do that, right? Instead of sending the traffic from one WAN edge to another WAN edge, you can do the TLOC rewrite. So the next of TLOC IP address will be modified with a new address.
Okay. Okay.
So we do have the lab 16th lab TLOC extension. This is what our scenario, and this lab I can configure and then I can show it for you. So if you want.
Yeah. So guys, you need any break or
Yeah, with
Yeah, you
Yeah,
need.
yes, man. Yes, Naveen.
too much? Too much. But good, yeah. Today. So okay, now it's 4:40. So yeah.
10 minutes we will be back, I think. Anyway, I'm going to present. So you bring your coffee and then by seeing the screen you can do it.
Yeah. So yeah, bringing the coffee means need to prepare coffee and
I understand.
all are sleeping, so need to prepare and get it. So 15 minutes break.
Okay, then we'll just by 55.
Yeah, yeah, 4:55 will reconvene. No problem. So
So this is the lab number 16. Before we go with 16, so 11th lab, 12th lab is templates. 13, 14 is policies. 15 is just verification only. Show IPsec VPN tunnel, show BFT. So what traffic is going through which physical path. So 15th lab is just for verification. 16th lab T-lock extension, which we will do it. And 17th lab is just troubleshooting. So ping, trace route, we manage alarms and events, we shell system logs. So REST API is programmability layer access and then multi-tenant. Since like this is an optional one, you can try to deploy we manage and then we manage certificate and then adding vbond installing certificate. So this is the first actually task what we try to do, and along with that all the devices and unique device certification process we do that. So normally this is like you can keep it for your practice. So programmability is the one thing which we will talk about it tomorrow. But now tlock extension in our case topology, branch v1 and then branch v2. So I think there will be a cross connection between these two devices. This links will be provided with unique subinterface and then subinterface IP addresses. So these devices will become reachable. Like there are two links. They may try to bring one link down and they will try to use one link. So one link to internet and one link to MPLS and then extended connection, T-lock extended connection between them. So MPLS will be extended to branch V1 and to branch VH. So I think this link also they will try to bring it down. We'll see what topology configuration they try to do. So this is to check show BFT sessions to verify number of VPN tunnel runs, gold, silver, and then gold. BFT sessions, gold. I think they are going with some template. We have made so many unnecessary changes, but anyway, we'll try to do that. Copy the template, and from here we will try to make. Run through the lab, and then I will parallelly tell you like what are the configurations these devices are going to perform it. So first step should go with the CA. So branch CE1 and then new session, branch V2. Now two devices I connected. So branch router, we will check show BFT sessions and then with tab. So notice that you will only see local T-locks color for the gold and then silver. So local color gold and then silver. So both the links are enabled. Using both the links, this has enabled the VPN tunnels. Go show SD-WAN. BFT sessions, pipe and then tab. Okay, so so we do see gold and silver due to the restrict option. It has formed the VPN tunnel from gold to gold and then silver to silver. But at this T-lock source T-lock color, it shows gold and then silver both are connected. And then we go back to branch VE2. So this is also local color, gold and then MPLS. Show the FT sessions. So this is with the gold and then MPLS. And then they are making different color communications, gold, 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 and then MPLS. I think MPLS to MPLS, gold, same color only, but two different colors are wrong. Okay, so in this picture, so branch VE2 is displaying the information about gold-based VPN tunnel, MPLS-based VPN tunnels, and its associated BFT. Branch V1 shows gold and then silver related informations. Okay, so the first step to copy the existing device template. So we go to CH Cloud device template gold silver, and then we name it as a TLOG extension, and then we attach this to branch drop once we have finished our edits. So we are going to copy this template, and we will make configuration changes on this template. We will attach to them. Edit template and remove the silver transport from the template. See the below changes. Okay. So now I will go back. I will copy this. Make a copy of this. So we explode VPN 0 template. So first I will copy this template and go to vmanage, and then templates. So device template, CH Cloud device template, gold, silver. I think it is not there. So anybody has completed lab number 11? Because I did not follow the lab guide, and based on our configuration, based on this I implemented. or what I can do is I can use this template. I think this is the one we choose. Okay, I think not needed. I will make use of this. So IBM device template CH1. This is the template I created using the lab instruction. Maybe I can use it from here itself. CH Cloud device template gold silver, and then I will use this device template. I implemented this based on all of the template details. So basic information, transport, VPN 0, gold, silver. So this is the configurations I created. Okay, anyway, I will make use of the same template. CA Cloud device template gold, silver, and then this one will be renamed. Name it like CH Cloud device relocation, and then attach it to branch C1. Once we have finished our, then you need to edit template, remove the silver transport from this template, and then save changes. Now the transport and VPN. So we have gold and we do have silver. So this silver interface we are removing from. So that means as per the topology, we do have gold and silver. So this link will be brought down. So this branch V1 to gold and silver will be down. Branch 2, I think we are going to cut down this path. Lab removed and I saved the changes, and then now make a copy of that and edit feature template. Name it like VPN 0 template Tlock extension. Go down. Okay, so go down to V4 route, the default route to the silver transport. So we have created a default route using the silver transport, and that default gateway, another default gateway 129 pointing to 23. So this IP address or this particular default gateway has to be removed. Go to the so IBM VPN 0. Gold, make it as such with silver. VH Cloud VPN 0 template. VPN 0 feature template. Then edit. In the feature VPN 0, will be 0. Move to device template ch1. If you follow the guide, so I did not use this. That's why. So I just used IBM VPN 0 feature template. So this is the one I need to update. You need to remove that will happen. VPN 0 feature template. We added two default routes. How come this entry is removed? I don't know. Okay, and we will create. That's okay. I think this is not going to create any issues. Because under the IP route only, I determine the route with the next hop, but nothing is visible in this place. One one seven eight. Update. So one default route I presented to this VPN 0 feature template. And we create a new feature template and on the CH cloud router, Cisco VPN interface, Ethernet, and then change to no and port number 4. So fourth port number. So now this port 4 will be used for this. So Ethernet port number 1, Ethernet port number 2, and then some of the physical port numbers pointing to this. So fourth port number and then fifth port number, we will be initializing it. To enable one port number under a new VPN. So Cisco VPN interface and the description, and then it is enabled, and port number 4 will be connected, and there we have sub interface, then second sub interface. So there are two sub interface connected for these devices. So I will create the same name, CH Cloud Tlock template. So go to feature template. VH VPN. We will create it for VPN interface Ethernet. Can be used for management VPN 512 or transport VPN 0 or service VPNs. I will choose this. So this is a CH. The name also will CH Cloud Tlock template. Tlock template. The same thing. I will bring this interface up. So one physical port with two sub interfaces. We are going to use it for Tlock extension. And interface name, fourth port number, gigabit Ethernet 4. So as right, we are enabling the physical port, and we are making the physical port number is 4. We do save this. On the physical port, we don't assign any IP address. Create sub interface on top of that. So another new feature template for CH Cloud, and this is Cloud Gigabit Ethernet 4.10 C1 template. Here 4.20 C1 template. So there are, go back to add template, cloud, VPN interface, CH cloud. Now we can use it. C1 template. GI. There is name available. Yes, so first sub interface we try to make, and this port will be brought up. Is 4.10, the sub interface. Four dot 10 sub interface, and then IP address is device specific. We will assign it manually, and then MTU 1496 TLOC extension, global and gigabit Ethernet 2 port. Okay, so IP address we make it as device specific. Secondary IP address is not here. This is not a tunnel interface. VRRP, ACLQoS, and then .1x. So IP MTU, we just reduce it. In 96 bytes. Yeah. So we will enable the TLOC extension, by default not enable. So we will make it as TLOC extension with global gigabit Ethernet 2. So this is the configuration I'm trying to do. Okay, just to understand, this is port number 2. Okay, and when you want me to cross check, I can show that also in the CLI mode. Show IP interface brief. Now we do see gigabit Ethernet 2, gigabit Ethernet 3. So gigabit Ethernet 2 is with 117.11. You can see here, this is the IP address. This is connected port. Gigabit Ethernet 3, it's going to the silver transport, but we just remove this interface. Then gigabit Ethernet 1, it goes to the LAN boundary. As per the, it goes to this LAN boundary. But all testing interfaces. So now what we try to do, we create one sub interface. This device, this is a 4th port connected with each other. 4.10, we create sub interface, and this will be extended, TLOC extended to this through physical port. So gigabit Ethernet 2 will be extended to 4.10 sub interface. We are extending to this WAN edge device. This is the guide and its related configuration. So we are creating 4.10 and we are extending gigabit Ethernet to physical port. I will save this configuration. Okay, so I created one interface. Then similarly, we will have to create the second sub interface. Add template. Use cloud keyword. We choose CH cloud. Wait for CH. This is I think typo. This device is an C edge router, but we are choosing it for CH cloud router. There is no device called C edge router. Give me a minute. I will delete this. Yes, this is like a configuration issue on the template. So we are attaching to branch C1. So obviously this is a CSR only. Wait, D1 CSR 1000 and VPN Cisco interface VPN. We'll use our own name. I think this is the better. IBM and then CE1 gigabit Ethernet port 2 template. I just bring this second port up. So fourth port is up. This is connected and then interface is gigabit Ethernet fourth port. So I'm just taking the fourth interface up using this template. And then one more configuration as add template, sub interface configuration for CSR 1000 and the VPN interface, Then I can give it IBM CE1. So G. That's what I think I'm doing a lot of careless mistakes. Yeah, fourth port, but the name is supposed to be 4. The fourth port is a TLOC extended port. I'm enabling and then updating with fourth port number because this is the port number we are supposed to enable it. So gigabit Ethernet 4. From here, we do create 2 sub interfaces and we do specify IP address for them. We add it. This CSR. VPN interface. I can give is IBM, then CE1, CE1, gigabit 4.10 template. So this is first sub interface template. I bring this physical port up. Gigabit Ethernet 4.10. So this is a syntax I will use it. And then IP address will be device specific, MTU, and then extension. So MTU 1496. So 4 bytes they reduce. Now this is extending to physical port number 2. So TLOC extension. We bring it global and gigabit Ethernet 2. So this port we are extending to port number 4.10. So for one sub interface. This. And similarly, we create one more sub interface. CSR 1000B. I will create a second interface is this. IBM CE1 G-4.20 template. Global specific, and this is enabled. The interface name is gigabit Ethernet 4.20. Device and IP address device specific and tunnel interface is on. On and 420 tunnel on, and then we make the color as MPLS. And strict is enabled. And then MTU 1496. One four nine 1496. Just choose sub interfaces. So one with TLOG extension and one will be with the specific tunnel interface. I believe you can hear what I'm trying to do. Here there are two sub interfaces created. So between WAN edge 1 and then WAN edge is created. So one is 4.10 sub interface, and another one is 4.20 sub interface. 10 is extending the TLOG. Now this 4.10 configuration, and this was extending. So this second port was extended to this sub interface into these devices. Now this 4.20 we are going to take it from MPLS. So we just configured this port as an MPLS port. So this place 4.20 is configured as a tunnel interface. So VPN tunnels will be triggered, and when this is connected, this will be connected to MPLS color, and color restriction we enabled it. The same vice versa configuration should be applicable for this device as well. Now when this is connected, one side it is going to talk to MPLS, and another side gold, or maybe you can shut down this physical port, and two sub interfaces. So first sub interface is performing encapsulation, another one is doing the extensions. Then things will work of it. So this is what the configuration, and then we save the configuration. So next you need to add one new default out to the VPN feature templates. Okay, so called VPN 0 template extension, because this next hop IP address will be pointing this TLOG extended IP address. So the next default gateway will be through this. Template, VPN 0 templates. Install created a new template. It's we template. We click this, edit. So 000, and then we add 120.20.2. It's not saving it. Added a new next hop IP address towards to the TLOC extended interface. Then update, change, configure the devices. Default gateways. And then we will modify the complete template. So CH Cloud device template. More VPN interface, VPN 0. Gold interface comes in. CH Cloud.tlock. And first interface, second. So physical interface, sub interface, and sub interfaces we will call under the VPN 0 port. These things. Under VPN 0, we will have to add VPN interface Ethernet. This is interface. Add two more. One is here. One more. So we try to take 4.10. So 4.10 I selected, and similar way I try to choose 4.20, this template, and then I will update. These are three templates participating in the T. 4 interfaces. So according to this vantage, there's got VPN 0, which is for gigabit Ethernet 2, and main physical interface gigabit Ethernet 4 in VPN 0, and then 2 sub interfaces. These 2 sub interfaces are into VPN. So there are 4 interfaces participating in VPN 0. Okay, it's updated, and then they're attaching the device with a template, and then we'll show for the informations. The IBM device template, attach devices, goes to branch C1, attach. So device specific parameters like interface IP address, Host name and system IP address. We just give a manual IP address for this. Four dot 10 and 4.10 assign with 10.10.1/24. 10.10.1/24. Issue updates. 4.20. Global 1.20.20.1/24. These two interfaces IP address. Apart from that, system IP address and route ready and other configurations are already determined. We just manually modified it. And then over the same device template, NAT configuration, NAT will be enabled. We will this. So, so I will update the device specific parameters. Feature templates. So, Glock extension. Just take a look, and there are so many meshes running over here. Because for this lab, the exercises are not good actually, because a lot of gaps and then a lot of information is missing. Because they are created for basically the device. So in this lab exercise, ch cloud device template, but this is actually a feature template. I think while you are trying to configure, it might not happen. Go to the feature and IBM. This is the interface. So the physical port supposed to enable with the NAT. Second port we are enabling with the translation. Gold interface. Interface, which is go to this gold interface, we are enabling the translation public IP port. So NAT type, whether it is a interface, pad translation, or dynamic translation, or loopback specific address. So we can make it as it's like port translation, and then we can update. Now I can attach this template. Otherwise, I can attach to this attach devices, branch 1. Then only system IP address and the host name. Host name is branch CE1, and then first device update. Then next. So TLOG extension related commands will come here. So side by side. So 4.10, 4.20. So these sub interfaces and then associated IPs. So you can say .1Q10, .1Q20. So these new configurations and all will be created. I will apply this. But still even same configuration to be applied to second device also. Then only the second device will function into it. Branch C1, and we can see the configurations. The NAT configurations will be enforced. Ethernet 2 will be enabled with IP NAT inside and then outside. So 4.10, we can find .1Q20 and then .1Q10 IPMQ changes. NAT configurations will get applied. And then other commands like interface creations and all the things. So select C1 and then press attach, and the other configurations we will try to map it. So once this is attached, and it should go to branch V. Then we do attach template for the devices as well. This is the configuration we need to do it till first device 172.110.1. We finish this. Then for the second device, we attach the template. This is a CLA template. In the CLA template, there will be a configuration associated with this. So we will do this also. So for the configuration template device, we choose branch V2 template, and we detach, and then we select branch to devices from here. And then branch 2, we just copy one more template called branch V2 Tlock extension, and then we are going to attach it. The standard template we will remove, and then we will try to take one Tlock specified template. So that could be sd-wan file, sd-wan branch v2, branch v2 Tlock extension. So this file is not there. Okay, sorry, I think we need to edit it. I'm sorry. It's still in progress. Then I will edit this configuration. To branch V2 Tlock extension. So we copy branch V2 and then we make it as a branch V2 Tlock extension. And commands the sub interfaces we will get it here. The gigabit Ethernet 0x1. There are two on this device. One interface with the gold we shut down, and when we bring this MPL. So here physical port is with NAT configuration. This is an extension port, no shutdown. First sub interface with the 10.IP address, tunnel and encapsulation. Second interface with this IP and Tlock extension to 02. And there are another default gateways presented, one default route present. We are creating two sub interfaces over here. And while we are attaching the template, Tlock extensions will be placed for both the devices. Why this is taking too much time? Show IP interface brief. The device is being configured, that's why it's not accepting the session. I mean, show IP brief. Now we could find 4.10 has come, 4.20 has come. It's in the deleted state. It's being configured. Let's wait for some more time. In the meanwhile, I'll prepare the second template. The template branch C2. So branch VE2 template, which is CLI based. I will copy template for TLOC extension. So this template I will edit. Under VPN 0, I need to add these commands. VPN 0. Remove all of interface gigabit 0x1 configuration and shut it down if it is connected to transport. So 0x1. So we need to remove this 0x1. Then interface G 0x 0x1. Shut down. Okay, and interface G0 below the IP address. It could be NAT. Interface 0x3. No IP address, no shutdown. G 0x interface G0x2 and no IP address and then no shutdown. So I need to give a no shutdown for this. I need to create sub interfaces. G 2.10 interface G 2.10 G And 3, we give IP address. 1.10.2/24 24 MTU 1496 tunnel interface, and then encapsulation IPsec color gold and no shutdown. Gold if it is needed, restrict. No shutdown. No shutdown. And then next sub interface. This is 1.10.10.2 IPMQ tunnel interface color restrict. This is 20th interface. This is 20.2 T20.2 IPMQ T-lock extension and G0/2. T-lock extension GE0/2, the physical port. No shutdown. With exclamation. To internet path. IP route 11.10.22. No IP route.
Parthiba, it is one or exclamation? I think one is given here.
The exclamations.
It is 91.
Exclamation.
Row number 91.
Yeah, I will modify this. IP route 1.10.10.1. Yeah, now it's exclamation generate.
Yeah.
So I now added these commands. Even any typo comes in, it will throw in a message. So I just edited. So branch v2 template I created, but let's see the status for IBM. It's not pushing. Branch v2 lock. So branch v2 template, there is a device. There are 220 templates. It's supposed to go to first one, branch C1. Branch V2 is in the local CLI mode. So I need to push template to device 1 and then template to device number 2. If configurations are successfully done, then TLOC extension will be presented. Basically, like we are about to form first tunnel over here, and then one port. This is extended to MPLS, and then one tunnel will be created. As per the lab configuration, this port number is 4.20. So 4.20 is extended. And then similarly, this device, this port is shut down. This port is shut down. And then this MPLS link, this MPLS link is connected. And then there will be a new extension on this physical port 2 heads here. So like two TLOC configurations. One is extended here. The other one is extended in this place. So direct tunnel for this IP address. This device will take whatever may be the IP address. Through this, it's like extended. This is like 4.10. So we need to have another interface. 4.10 sub interface. This extends internet to here, and 4.20 gets extends in this place. So two sub interfaces extending its like TLOC connections.